Hello guys, my name is Nikolaos Tsougranas, I'm from Athens, Greece, and I have 6 years experience building applications in C and C++ programming languages. At this tutorial, we will learn how you can build a search engine in C++ using some pretty fast structs such as a try and a heap in order to achieve um, responsiveness for our search engine. Um, After, let's discuss our sections. The first section will be about the requirements and the installation guide. The second session will be about how we can initialize our program variables in order for us starting writing code about our structs and our functionality, search functionality. After, we will write code about our main struct, which be the try and the map to structs. At the fourth section, we will create an input manager where we'll understand the wrong inputs, etc. The final section we will add functionality to our program, to our search engine, and we will add some more structs such as max heap in order to sort um, the scores, and we will create some basic search functionality for our search engine. So guys, this is all what this tutorial is about. So thank you for your time, and I hope see you at the next videos. Bye. Hello guys, at this part of the tutorial we will discuss the requirements. First of all, you will need to know some basic C stuff. And you have to know some basic C++ knowledge. You have to understand how C and C++ works, what is malloc, but I will explain it also inside the project. Inside this project we will talk about pipes, how you can communicate between some different processes, and we will, using all this, we will know, after all this, we'll know how you can create a search engine. A search engine. First of all, a basic search engine. It is a very, very fun project, but in order for us to start, we have to download some tools if you are on Windows. If you are on Linux, you will be fine. So I will download some basic stuff for Windows users only. And if you are on Linux, if you are a Linux user, you can continue. You cannot see the most part of this tutorial. Let's begin. First of all, we will need to download VMware official site. So we go here. The VMware is a virtual machine that you can download. So if we press download like that, download Workstation Pro. If you are a Windows user, you will use this. And here it will be downloaded. Will be downloaded. Also, In order for us to install um, some, I have already downloaded here, as you can see. So we will not use this, and we go here. We double click. We press yes. First of all, I forgot I have to install it from my system. Yes, I forgot to install a program, firmware player. Next, remove. Next, remove. In order to show you the complete installation. Excuse me. Give me a second. So now it will be downloaded, removed from my PC. Excuse me, I forgot to do this. So inside this tutorial we will learn a lot of things. We will learn how to use how to manipulate the console length, how to see the console length from our system. We will learn a lot of useful stuff that it is really important. Okay, now we will install it. You have to accept the terms. You may want to install, to restart sometimes the computer whenever needed. I will not use it right now in order for the tutorial to be continuously. So here we are. Finish. No. So in here we have to double click VMware Workstation Player. And here we are. I have already created a virtual machine, as you can see here, but I will create the new for the purposes of the tutorial in order to show you how you can create a virtual machine. So as you can see here, you have to download the Ubuntu software from the Ubuntu site or any other Linux distribution you want. So download Ubuntu desktop, and here these are the system requirements. You have to have a dual core processor, etc. I suggest you either dual boot your system or you have either to dual boot your system if you don't have a very good PC, because using a virtual machine is quite taxing for your PC hardware resources. So I suggest you either run a virtual machine if you have a good PC, you have a PC with good specs, especially processor and RAM. This is what matters. So you download it here. Nothing, let's say it is downloaded over here. I have already downloaded, so I will not use this. We go here and we go to our ISO that it is installed. This is our ISO that will be 64-bit or 32-bit according to what your PC is. In order to see what how many what the kind of PC you are running, you have to go to this PC properties. And see, here it is a 64 based processor. So you have to download a 64-bit operating system in order to take advantage of all the resources and all the resources and all the advantages of a 64-bit, which is better memory management, etc. So here we press next. Full name, let's say. I will use this. So temp, 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 temp. Virtual machine, temp, browse. I don't want to use my C drive. Will VMware, new folder, VM2, temp VM inside here. Next, how much disk you want to allocate? I will say 20 gigabyte. And split virtual disk into multiple files, it's a better choice. Yes. So now we can customize our hardware. I will, because I have 16 gigabytes of RAM inside my PC, I will allocate 8 to my virtual machine. And because I have a 16 core processor, I will allocate 8 cores. 16 threads processor, I will allocate 8 threads to the virtual machine. Inside the display, I will allocate 2 gigabytes of RAM because in my case I have a 4K monitor. So in order for us not to have any kind of bottleneck in some application, in 3D application, you have to accelerate 3D graphics. It is very important. And specify monitor settings. I will use only one. At this tutorial, I will use what most of you will have. It's 1920 times 1080 pixels. So close and finish. Now the VM will do all the job for us. Download anything that is required. Remember that before all this, it is better for you to restart the computer, as it is suggested by the VMware. Now it will run through the configuration by itself. So now we will wait a bit. And now it will copy all the Ubuntu, all the necessary Ubuntu files. Remember guys, now it's like if we are running a secondary PC inside our main PC. So if we press here and press full screen, manually it would go full screen. Excuse me for this. maybe because it hasn't configured the screen yet. Let's wait a bit. I will use 18.04 Ubuntu, 64-bit software, as you saw before. Here, if you press the arrows, you can see some different excuse me, you can see some different tips how to use the Ubuntu OS. It has some pre-installed software such as Firefox, LibreOffice. You can customize your appearance, the language supported, has a lot of language that are supported by the Ubuntu software. So we have to wait a bit. Also for this tutorial we will use an editor. You can also use the IDE, but I suggest you using an editor in Linux, because after that we will create a makefile as well. So the editor that we'll use is Visual Studio Code. We have used the same editor at our previous tutorials as well. It's a free editor, that's why I'm using it. Also, everything that I'm using is free, including you can install Windows 10 if you want for free, but it will say here that this is not activated, but you can fully use them without any problem. Moreover, the VMware is absolutely free because we are using the non-commercial use only version. And finally, of course, the Ubuntu software is free as well, but you can donate to it to support the cause of Linux and Ubuntu distribution, of this Linux distribution. It's retrieving the files right now. And now all the language packs are downloaded, and after we will configure the installation, the VMware workstation installation. This tutorial, I will make you a quick walkthrough what we will do. We will create an algorithm that will count how relative a certain file is to what we are searching, to the key, to the search key that we typed, in order to show to the user the most relative paths. Um, the excuse me, we will use also um, a really fast uh, type of struct, which is called a try. I will show you right now very fast. Try, tree. Um, so a try, as you can see, let's say we have the word to. First we go to T, after we go to O, and if a word like that is given, then we will write down where to is found inside our files. For example, in folder psi in file psi.txt, it's found the word to at certain lines. Um, Moreover, we will create some other very useful stuff, such as how many words there are in our tree, in our in our documents, and how many letters, and some pretty cool stuff as well. So we are pretty close to. We are pretty close. First of all, you in order to have the cursor released from the VM, you have to press Ctrl Alt, and it is released. Right or left, no problem, it's the same. Now all the tools are installed, so we have to wait a bit for that as well. The time for search is log n for the try. It's pretty fast actually. For the try, pretty fast. So we use this type of struct in order to achieve a faster searching time. And my how I'm seeing this program run is we have a master thread, a master process where it will read everything from the keyboard, and then it send then yeah it is sent to we have a worker processes where these processes are actually reading what the master thread sends, searches through the document, and gives back the answers. Each worker will have certain folders to read, for example 3 or 4 folders for example, and it will be balancing between them in order to have a correct way to search and not have a correct way, to in order to have all the workers the same time to search in order to be faster. So here we are, everything is ready. As you can see, it's full screen. You can press here full screen, and it is full screen. It's like if you are using a native Ubuntu installation inside your computer. It's pretty fast, I'm not gonna lie. VMware, it's pretty fast. So now we are getting prepared. As you can see, everything everything is ready. So inside here we are, Ubuntu is saying to us where everything is located and how we'll use. If you're not familiar with Ubuntu, I suggest you search some, pause the tutorial and search some things. Actually, let's go back. Okay, everything is done. And now we want to download some pretty important stuff in order for us to run C++. So first of all, you have to go to Ubuntu software, and here there are some developer tools. If you press here, and if we don't find Visual Studio Code here, if we don't find Visual Studio Code here, we will go from Mozilla Firefox. We found it here, no problem, and we press install. We give our administrator key, our sudo key, otherwise, and we will wait till it is installed. This is installing right now. We can install our Ubuntu software right now. Actually, maybe I should have pressed install later. Temp. Actually, cancel. We will. You can install it on your own, because I think we have to restart our VM, and I don't want to use it to do it right now. We will wait till the Visual Studio Code is installed. A few moments. Ubuntu is pretty cool for development purposes, especially in C and C++, because most C and C++ software and will be run in Linux distributions. So I suggest you, it's better to write C programs running in Linux and not in C++, not in Windows, for example, because it has some different functions in Windows. But every program that is written in Windows can be written in Linux and vice versa. It's if you change some functions. If you see my other tutorial about how to build a keylogger, I have recorded about 20-minute session how you can create a cross-platform function, how to make the program cross-platform. Now we will launch it. So it is launched. And now we will use C and C++, we want to, as we will use C and C++, we want to download some language tools. So I suggest you C and C++ intelligence debugging a code debugging here, which have some pretty cool uses. It supports GDB and supports a lot of stuff. Um, first of all, I want to show you something. So let's create a new file. Include. First of all, let's save it to the desktop because we will erase it later as temp.cpp, as will be a C++ file. Include IO stream int main void here, and of course we want to use using namespace std every time, and first cout hello world and L. So we want to press, as you can see here, Control and the tilde button. So Control here, and we open the terminal. Otherwise, I will not use this because I don't like that much. I will use right click, open terminal, cd desktop, and here we have a terminal. The terminal placed inside our file. I will have this as full screen, and I will have the terminal in front. How now we can have the terminal always in front of our code? The way to do this is right click, always on top, and even if we change the main window, as you can see, I have pressed inside the Visual Studio window. Even now, the terminal window is not hidden underneath my main window. So now we will run our program g++ -show temp.cpp, and as you can see, we have to install our g++ first. So sudo apt install g++. We have to give our password again. Yeah. And now it is installed everything. According to your network speed connection, the time will vary. The search engine that we'll use, just to clarify, the search engine, it will be accessed by the terminal, but it is not difficult to be accessed by the web as well. It's pretty easy, but we will not use this. We'll access it from the terminal. So everything it is run. But because we want to install our make file as well, because we will use a make file, I will decide after if I will start from the beginning to use the make file. Make file is a way in order to just using make command, just pressing make like that, all our C++ folders, not folders, or our C++ program will be compiled, because at the serious program where a lot of C++ files and a lot of .h headers files will be present, you will see that it is really important in order to have the code organized. You will have to write multiple windows in multiple different C++ files in order to have the program organized. For example, if you have an input manager, you have a different file, for CPP file for the input manager. I think this is what we will do right now, because from the beginning, and I will not do a separate video at the end reorganizing our code to a C++ in order to show you how you have to correctly manage and write your code when you're writing a big big C++ program. Uh, so, as you can see, excuse me. Okay, we installed our make folder, and now we will rerun again our temp, and it is compiled without any errors. So if we run temp, hello world, and now finally we have to create. Actually, I will create a basic CP make file, but before this, I want to install our C++ IntelliSense. So install, and it is installing right now. We have to wait a bit, and was installed. It is from Microsoft, and it has a lot of help, help and errors, squiggles, etc. In order to activate, we have to reload it. So here we are. As you can see, it gives us our recommendation because nothing was given. And L. So everything it is perfectly installed. Now I will create a basic make file for you. In order for me to do so, desktop, excuse me. I will show you. This is how a make file it is written, a correct make file. This is how our final product will look like. So let me write a simple make file for you for this program right here. It will be a very simple make file actually. Actually. Let's Control N, cc equals g++, cpp flags minus g wall would be the flags that we're using. Default temp, excuse me. We'll write it as a make file, so everything it is nicely presented. So In order to run our temp, will be our temp now will be our excuse me, will be what we are heading, will be our final product of the make file. So in order for it to run temp, we have to, actually let's give it another name, project 0, in order for you not to be project 0 or executable. It's better. So in order for it to run will be temp.o to be compiled, right? Temp.o, excuse me. So in order for temp.o to be compiled, we'll want cc and the flags right like this, and after that minus o, and this will be here we will write our name executable and temp.o. As you can see, in order to run executable, we have to we need temp.o, and this is our command of how the temp.o will be converted to the executable. So in order to find our temp.o, we have to go to, we have to create we have to tell the make file how it can create the temp.o. So temp.o, in order for the temp.o to be written, it needs temp.cpp, and after that, and after the temp.cpp, it needs cc, the cpp flags. Give me a second, I made a minor mistake, and of course minus c temp.cpp, and after we will have a clean function where it will clean all the .o files. So make ls, for example, to see that the make file is present, make, and everything it is run perfectly. Now if we do make clean, it will remove all the .o files. Let me do it again for you. Give me a second. Excuse me, yes. First of all, view, I need to zoom it a little bit. I think like that, yes. I think now you will be able to see it better. And excuse me for that. And I will zoom in a little bit inside here as well. Zoom in like that for you to be better. So right now we have the executable with this temp. If rn temp, now we don't have the executable. We have just our temp.cpp file. So excuse me, rm executable. Yes, now we have only our temp.cpp file and make file. In order to create our executable that we want from the temp.cpp that it is compiled, we have to run our make file. So make, and our executable is written. As you can see, ls, and the temp.o is still present. If we press make clean, the temp.o, it is that we don't want to use it anymore, it is deleted, and we have the executable. If we press executable hello world, as you can see, it is a lot of work, but you will understand later how important it is, because we don't have to, if we have, for example, 10 different files, we don't have to manually run the .o to manually compile every file of it in order to have the binary file, the .o file, and after we will have a really big a line, like for example g++ minus o, the name of our executable, for example mini search, and after all that we want to add next to it. So from here I will show you one last thing, how you can default, executable and clean. I think this is the way where, yes, when we do make, it goes here to the default, and after it runs the executable. The executable contains this part of the make file. It runs this part, and when we call clean, this part is called. Remember, it is it's very important to run the executable, to have a make file and a big C++ project, because it will take a lot of time and effort to divide the code after, in order to be easy for you to code, and easy for you and the others to understand what each part of your code is about. So guys, I think that's all for this tutorial. We wrote a mini make file, we wrote a mini a mini program in order to demonstrate to you how a simple make file is written. Remember that inside here will be a lot of lines of code like that over here. You may have a lot of so imagine if you don't have a make file, you will have to compile every single of these separately, which is a lot of time, and after you have to write all this line down in order for it to run. If you don't have a make file, you have to write every single line of it, and finally this line as well. And of course, after that, you have to delete every file by yourself. So guys, I hope you have understood how make files work. It's actually pretty simple if you get the idea, and how a simple VM, the VM is works. So now we will close the VM. Actually, the best way to close it is press exit, power off, and the VM is closed. After you go like that here, and the VM is closed. So guys, thank you for your time. I hope you had fun, and you understand how much you will learn through this tutorial. And I hope to see you at the next videos. So bye guys. So guys, at this part of the tutorial we will start writing our project. First of all, we will write I will do an overview of the project, and we will write what arguments will be given when we execute the program, and some stuff you will see while we are continuing. So okay. this will be our main program. So mini search to CPP. Also we'll create a header file. As I told you before, we will try to have the best um, um, we will try to have the best format that we can achieve in order to for me to show you what is the correct way to write a big project. This project will be around 700 lines, so it's actually not a big, it's a medium-sized project, but you will understand how important it is to have your code organized. So let's continue. First of all, inside here, we will include IO stream. Excuse me, first of all, I will save it. Actually, let's create a file in here. So let's cancel it like that. New folder, mini search. Let's put the mini search inside. Okay, like that. And inside here we will mini search dot h. Okay, here we are. Okay, actually let's change the name of search engine. Rename search engine, you know, in order to be better. So open with other application, Visual Studio Code, select. So inside the search engine, first of all, inside the search engine, we want to include search engine dot h. So include search engine dot h. Include here. Inside here we want to include for now only IOStream. It's input-output stream for the C++ for C++ program. It's the main input-output stream. So let's continue. Inside here we will write our main program. First of all, let's define what our program will be like. First of all, let's open terminal that. As I told you, always on top here. Let's rename it to search engine. Like that, it's better. Okay, here we are. And so the way I imagine our program, actually I decided to make it a little simpler than I told you so. First of all, because it will be really difficult for you to understand how to handle signals, etc. And some and not that easy structs in just a simple tutorial, mini tutorial. So let's zoom in a bit here. So I decided to make it a little easier for you. We will use just a simple file that will be like, the format of it will be like that. Excuse me. So control S, small data set.txt. So like that. 0, for example. 0 after a tab. after a tab, and here we will write a word, for example, uh, hello guys, how are you? I hope you have fun. Okay, we can write a lot of stuff here like that, and when we change a line, for example, let's copy this. As you can see, it's a big line right here. This will be a document. After we press enter, we write one. This is the second document. I love to play video games, and for example this will be an article about video games. And after three, hi boys, um, this tutorial will excuse me, right here, this tutorial will be about um, uh, some important structs. Um, so um, this will be our database, for example, our dataset, excuse me, and our program will search through these in order to find the correct which articles. Each one will be a document, an article. Which document or article is most relevant to the search query that is given. So when we start our program, the way to start it, I suggest, is something like that. For example, search engine minus a k, the small dataset.txt. Actually, minus d minus d is better from document, and minus k, the number of documents that will be shown according to the algorithm. So if we press 3, the 3 best documents will be shown. This is the way I imagine our code, no, not our code, our this is the way I imagine our program, and I'm sure that we will achieve this. So let's begin. First of all, as I said, the way that we will write is search engine, for example, minus the document.txt, for example, some document, minus k, a number, how many results will be returned. So first of all, let's check the arguments. So int main void, like that, and inside here we will check let me check again, search engine minus the some kind of doc.txt, document.txt. First of all, let's have it at full screen, a moment, and let's have it to be a little longer. This is an example at how it will be shown. As I told you at the previous tutorial, it will be always on top, in order for us to have a better, in order for us to, excuse me, for us to be more visible, because the terminal from here, it's not that visible, and I don't like that. I don't like it that much. Actually, it is useful, but not that visible, for me at least. Actually, I will increase a little bit the size of the letters like that in order for you to be more, uh, you can see it better. And for example, here we want to check um, how we will take the arguments from here. This is our program and these are the arguments. The way for us to take it is int argc car star star argv, excuse me, this is the best way to show it. So argc is how many arguments are given. So here are given 1 because this is recalled as an argument. This is counted as an argument 1, 2, 3, 4 and 5. So if argc 0 different to 5, cout, actually we forgot to use a namespace, using namespace std, cout wrong arguments. I will do now a demonstration to you. First of all, after we have to create a make file, of course. A make file is very important, as I told you at the previous tutorial. So, a make file like that, and inside here we will write cc equals g++, cpp. Actually, we won't use any cpp flags, only if we want to debug. Minus G I think is for debugging purposes. Default will be search engine. Excuse me. Search engine and clean, of course, because we don't want all the .o files to be present after we have compiled. And so let's begin. Search engine.o, excuse me, and inside here will be minus o search engine, and we want the search engine.o to be present. Search engine.o to be present. Okay, and in order for us to find where the search engine.o is, we want to excuse me, like that, search engine.o, search engine.cpp, and search engine.h, of course. This is not important, but we use it just for us to be more clear what it is needed for this to compile and to achieve this. So like that, minus c search engine.cpp, excuse, yes, I think this is correct. So if I press make, I have forgotten to install make at this machine. Oh my god, sorry. Give a second for me. So, yeah, I forgot to make the clean. As you can see, because I haven't used the clean, .o is present. We don't want this. So let's clean it. Clean rm, excuse me, rm star.o. Star.o means that we will delete every file that has a that ends with .o. So make So or only .o is called. As you can see, excuse me, as you can see, .o is not present. And if I run search engine, okay, give me a second. This is just a way to show you how args how argc is working. Make again. So like that. Minus d dot txt because we haven't checked it. Minus k2 correct args, but if we have given for args wrong argument, and it is fine. It works perfectly. So after we want to check some other stuff as well. So in order for us to be sure that the arguments are correct, of course. So we want to check if the letters are correct. Give me a second to find out what we will do next exactly. Okay, we will check if the minus d and minus k is present. So strcmp, in order to access each one of these individually, we have to go here, argv 0, like that, argv 0 is that, here, argv 1 is minus d, argv 2 is that, argv 3 is that, and etc. It will continue. So strcmp argv1 minus d, strcmp returns 0. So yes, it returns 0. So now you will see strcmp minus d and strcmp minus k, strcmp argv3 minus k, see out wrong arguments. In order to use strcmp, we have to include the C string if I remember correctly, yes, and like that it is wrong argument because we have given the last, it's correct argument. If we change that with for example f, wrong arguments, as you can see. So after we have to give, and actually when wrong arguments are given like that, we will return the program, return we will close the program. So return with an error code message, return -1. Okay, after we want to check um, we will actually we will toy this that we will using this we will return a number. So for example, so if we have cout, let's say please wait, because it will need some time for the program to initialize the database, to initialize our structs. So we'll say the user to wait in order not to write anything to the keyboard. And we'll need some numbers in order for us to later access the try and the map. And so how I'm imagining the program. So we have the small dataset here, not like this. Here we are. So every line of it will be stored to the memory, and in order for us to access it faster, so when the program initialize it, every line of it, every document of it will be stored in a map on the memory, and the try will define each word where it is stored exactly at the document, inside each document. A word is defined by a word actually is when it is separated from the previous or the next with a space. This is what a word is. For example, this is not this is one word, not two words. doc.txt. So this is how it will begin. So we will need, when we get the lines from here, in order to initialize the map correctly and the try correctly, we need to know how many excuse me, we need to know how many what is the biggest line, first of all, in order for the map, because the map will be actually an array, let's say, of different documents. So we want to need what is the biggest line in order to initialize every time the biggest line, and after we want to know what is the number of lines in order to allocate memory for the correct amount of excuse me, to allocate memory for the correct amount of lines for the map. So after this, let me close this. Perfect. So we will need a line counter, int line counter. Counter will be equal to 0, and int max length will be equal to -1. And we will attoy the k. Attoy means that we will convert it to an integer, string to integer. Int k equals attoy argv4. So let's see out k in order for us to be sure that it's correctly converted. Haven't make it again. Make 2. If I press, as you can see, it's perfect. So after that, we want to read the sizes. we want to. So now we have finished with the main. Um, Now we have finished. Um Excuse me. Yes, now we have finished, and now we need uh, to read the sizes of um, of the document, of this document here, the small dataset, for example. So the way to do this, um, actually, as we have finished. The way to do this, okay, let us do something more. Um, we will check, of course, if the file is correct. We will check it really fast here. Uh, file star file equals f open. Um, arg um, will be argv2, I think, and we want to open to read this file. So if file equals null means that the file is not opened, so cout, that we will tell to the user that the file that it is given to us, it's not correct. Error opening file and del. So, excuse me, let's make it first. Error opening file. If we press here small dataset.txt that exists, please wait. Nothing is returned, so the file is correctly opened. But of course, when we open a file, of course, every time we have to close it. Fclose file. So right now we have managed to write the simple make file. We have managed to read the input, correctly, and okay, I think that at the next tutorial we will we will read the size of we'll read every line and how long is the file, the small dataset, and after we will pass it to the map, and we will split the words into a try. Of course, first I will have to explain to you what a try is. It's not an easy task for me to explain. It's a difficult, not too difficult, but it's a struct, a more advanced struct that it's used mainly because it is very, very fast. And I think that if we have time at the end of the project, we can do some modifications to the try in order for us to achieve even better times than what we will achieve. We will achieve. And so, guys, I hope you are interested in this project because we will learn a lot of cool stuff. Who can see how big how big um, the terminal is in order for us to underline the correct words from the search query, etc. It will be very interesting, and I will see you at the next video of the tutorial. Bye. Hello guys, at this part of the tutorial we will try to initialize our map and our try. Our map actually tried a different video, I think. So let's start. First of all, this part here, let's erase it for a moment. I I write it quickly in order for you to show how we can check all the arguments, but we will integrate it into a different session in order for it to be better. Um, so uh, let's begin. First of all, we will create a new CPP folder, which will be called read input, excuse me, read input.cpp, and another one again, which will be called read input.h, and what else? Actually, I have made a mistake over here. We have to, it is common use when we refer to a folder, a file, excuse me, CPP or H, to have caps lock on and not the first letter at least, like that. It's commonly used like this. So I just delete the search engine .h as well, and we will file open folder, and we will open this here like that, and now we will delete this like that, like that, like that. Actually, this cannot be shown, of course. So we have the search engine, we have these two. So read input.cpp and read input.h. So first of all, we want inside here to include IOStream again, of course. Include IOStream again, IOStream. We're going to include, actually we will see later what we want to include. Inside here we want to include, excuse me, we want to include read input.h. We want using namespace std, of course, always, and we want to read the sizes. As I explained to you at the previous video, inside here we want to read how big is it, how many lines has the document inside, in order to allocate the correct amount of memory, and what is the bigger line. So inside here we want actually we want to connect it with the CPP. So inside search engine, you want to include the read input.h like that. Include read input.h, and inside we want to read the sizes. In order for us to read the sizes, this is what the sizes represent. So in order for us to do so, we have to pass the sizes as arguments inside the read sizes. But because we want to use them again, we want to pass the exact memory location of these two. Because if we pass them like that, for example, read sizes, line counter, max length, and we pass, of course, this argument over here. argver2. Every changes that will be made inside here, inside the read sizes function, it will not affect these two. So we won't know the exact number of these two at the main program. So we want to pass the memory location of of these two in order for us to know what changes are. So we go here, read sizes, and because we have passed the arguments like that, int star line counter, uh, int star max length. Prefer it like that. Give me a second. And of course car star doc file like that. Perfect. We have to pass the definition of the function, the declaration of the function inside rend input.h. So it is a int a function that returns int type of a variable, read sizes, int star line. We go like that here. Excuse me, like that, and it is perfect. In order for excuse me, in order for this file to know when .h is passed, in order for this file where we are here, it reads the read input.h. Read input.h is right here, and CPP includes read input.h, so .h here knows that read sizes is present inside here. Of course, we want to make file to write the make file right here. So in order to, as I said before, we need search engine.o, but as well we need read input.o. So like that we are here. First of all, we will change something. It is better that way. I think like that. So here we are read input.o, and here we need read input.o like that, and we need to create the read input.o, and so in order to create the read input.o, read input.o, read input.cpp, read input.h, cc minus c read input.cpp. What is include search engine? Yes, and inside here the correct way is that. So everything is compiled perfectly. Read sizes, you can see how it is compiled very nicely. Actually, place the make file at the last. Here, the search engine right here, it's better organized. Cout hi. Hi, as you can see, it's perfect. So, hi, or perfect. So inside here, inside read input, we want to check. We want we want to check again if the file is correct. So file star file equals fopen doc file r. So if file equals null, again cout error opening file and L, and we will return to the main function -1. So we want to change this, um, like we want to change it like that. So if read size if -1 equals -1, uh, just it will just return um, actually let me because we have two different um, times that it will return -1 when the folder is empty or where it is, or it is error. So error opening file, and cia okay, it will just return -1 here. Perfect. What else? And of course, right now, read sizes, and now we will create a buffer, a way to read each line separately. So because we don't know what is the length of each number of each line, because it will vary a lot, such as for example this line contains, let's say, 1000 characters, this contains 20. So we have to find a clever way in order to achieve a correct representation of each line. So the length of each line. So we will have right here an array of lengths. The way to do that is like that. We'll have line counter, an array of lengths. Actually, we will do it universally. We will we will just take the biggest line and allocate the memory of the biggest. This is not very good, but maybe be able to fix it later. We will be able to fix it later if we want it to. So let's begin. So car star. Actually, it's better to do it here. Car star. Give me. Excuse me, guys. Sorry for that. So, we are. So we want now to create a buffer. The way to do this car star line, we initialize a buffer variable with null. After Okay. After that, we um, after that we will have to initialize a size buffer, size t, uh, which be this will be, let's say, a buffer, a false buffer, because we will not use it anywhere. We will use it only just for the function to return the size of the line that has been allocated. So, um, let's say false buffer, let's call it, because we will not use it now at least, because later we may use it. Car length. So we want to read every line of the document until there is no more lines. So while -1 di -1 different car length get line is a function that it is used um, um, that it is used mainly for to get its line. The way to read this to I think that it is inside IOStream or CString. I'm not sure. So get line. We pass the line. We pass the false buffer, and finally we pass the file that we want to read from. Perfect. And inside here, give me a second. And inside here, we will every time we see a line, we will increase it. This, remember, guys, this is just used to count how many lines we have. There is no other way to achieve a, um, a program that it is well allocated, has fine memory allocation without doing this. So we lose a little bit on initiation time, but we gain a lot at memory management. So if star max length minus car length, so what we are doing now, max length is the length of each line, okay, the biggest line, excuse me. So max length is initialized with -1, right? So we are saying if the car length is what is the length of the current line read by the getLine function from our small dataset.txt file. Excuse me. For our small dataset.txt file. So if our car length is bigger than our max length, then we want to change our max length with the current length. After, we want to increase for each time we want to increase the line counter for each time we read a new line in order to increase this buffer. After every time, remember when we use this function where we want to free the line, first of all we want to null the line because it may contain some stuff that we don't want to use. Moreover, we want to false buffer equals 0. So what false buffer does? False buffer when this is how memory will be allocated. So if get line, if false buffer was 10, it will get just 10 characters. If false buffer is 0, it will allocate as many characters as needed till we reach um, /n, since we meet the new line character. That's why we use false buffer 0. After, of course, we want to close the file. Close. Excuse me. Close file. We want to free the line. Okay, and now we want to check if line counter equals 0 or max length minus 3. So we're using max length minus 3 because this means excuse me here, this means that, so first of all, if line counter 0, this means this is empty, this is like that, so no point in searching, in accepting any kind of query. If the max length was minus 3, each tab is counted as a space. So if max length minus 3, this means that the biggest line was like that. So the document will be empty, so there is no point in searching anything again inside here. So this is why we are using this. So inside here we will write what will we write here? We will write first of all, if nothing of this is true, we'll return 1. Okay. Here we will write cout we will write document does not meet requirements. So let's check it. Search engine, please wait, and after let's say here we will write cout like that, in order to have a more beautiful piece of code. Initialization finished. We'll write here, and right here we'll return 1, of course. So let's make and let's run. Initialization finished. If we erase everything inside here, document is too empty, does not meet requirements, and initialization is not finished, as you can see. If we write like that, it is like that, and no need for that, my bad. So as you can see, we have done a mistake. I have done a mistake. So the length will be 1, 2, 3, 4, 4. Actually, let's write here what is the max length over here. Line counter, cout line counter max length So let's make it again. Line counter 1, max length 5. So like that it is 5. So if I change this to 6, I forgot to make it, document is too empty. But if I write something, perfect. Max length 8. Remember that we will use only this right here, nothing more. Um, so um, this is what we'll use. Actually, we can erase because line counter was 1. Okay, we can erase some after when we do the mapping. We will check. We'll check if everything is correct, because this has to be correctly put together, etc. It will not be a simple, just a simple document. So let's write like that. And okay, redeem with CPP. After, um, actually, let's delete those two lines. We actually the initialization we may need it. The line counter max length we don't need it. So perfect, initialization finished. And now, actually, I want to test something. I will give it to it a different dataset. Home, desktop. Actually, let's give it a bigger dataset just for a moment. I have on my computer. Give me a second. Um, Let me delete this. Press it not all purpose. And big dataset right here. Okay, like that. So like that, max length for 26. The big data set, it's a TXT that will be given to you. Open with other application, Visual Studio Code, select. It actually, as you can imagine, enormous. And now we will try to run it. Make big data set. What I made a mistake, yes, like that. Line counter to 2225 and max length 25491. Max length of a line of a document. So line counter max length work perfectly. We may tune a little bit the max length because after inside the mapping process, because we won't need to have the 5 or 6, I don't remember correctly, um, first where it is. We don't need to have these two first. We may change our protocol without a space. We will see. Actually, let me see a little bit. Give me a second. I think I have made a mistake over here. As you can see, minus t is not counted as 1 inside here. Okay, no problem about this. As it is a txt file, we will keep it like that. So guys, I see you at the next tutorial where we'll write write how we can write the map down, and it will be pretty interesting, trust me. So bye guys, I see you at the next video. Bye. Hello guys. Now we will try to pass to create the map. So in order to create the map, first of all we want to take advantage of the line counter of max and max length variables that we managed to read from the last video. So what we will do now is we will create a new struct which will be called my map, and inside this struct we will initialize the struct and some new stuff. So in order to initialize the map will be called my map star my map. What we need to initialize it correctly is the line counter and the max length, as you can imagine. After, of course, we haven't created it yet, so that's why the errors. Actually, let's create it pretty fast in order for us to be error free. So now I will show you how you can create a class. My map will be a class, not a struct, will be a class, and now we'll show you the correct way to write down a class. So I will. We don't need the read input anymore. The search engine, I think. What else? We'll need later the read input. So the search engine, we need it. So now we will create. Give me a second. We will create the header file of the map. Map.h will be called, and we'll create a new one we'll call map.cpp. Inside map.h we want to include iOS stream, of course, because we will use malloc, we want to include stdlib, like that. Later we will see what we want else to include. Furthermore, now we will using namespace std, like that, and now we are beginning to write a class my map, like that. We'll have int size, my bad, int size. This will be the number of documents. Int here we have to write like that. Int buffer size will be this will be the length of the biggest document, like that. Now we want to have different array. We want to have an array of strings for each document. Each index of the array of a string, it will be an array of strings. Each index of the array of strings will be represent as a different document. So car star documents, each document, and right here we will have the length of each document. Yes, excuse me, of each document. So now we will write the main functions. So now my map, this will be the constructor, int size, int buffer size, and this will be the destructor. Now we have to go to the CPP folder, and we have to include map.h, of course, and we want using name space std as always. The search engine inside here we want to include map.h. So now a new my map line counter max length. Is inaccessible. Why it is inaccessible? Yeah, because I forgot to write the public part. Public, like that. Now it's perfect. Now we declare. If you know C++, some basic C++, you know that these are the variables that are not visible to the outside world of the class. It's only visible inside the class, inside class functions, and these are the public parts where we'll have setter and getters in order to access these variables. And so we go here, the search engine, I think it is not inaccessible right now. It is not inaccessible right now. Maybe it hasn't renewed yet. So my map, we have to go here, and this is how we declare a function. So my map, int size, int buffer size, like that, and this is initialization list. This like that, size, buffer size, like that. So, as I told you before, what is I will explain to you as the best of my abilities what we are doing at each line. So it is here my map. it return this is called here an initialization list. This line it says pass this size and buffer size are not the size and buffer size of there are the size and buffer size that is passed through the user. It is so it is these two integers. So we are saying that the moment that my map is going to run, first initialize this dot size with size and this dot buffer size with this. It would be equivalent to write this dot size equals size. This will be equivalent. So now we want to allocate some memory for the documents and the lengths, of course. And after, when we destroy the map, when the program is closed, we want to deallocate it, of course. So, document, document equals car star star malloc size of car star this would be the same. Actually, it's better to write this dot size. Lengths equals int star malloc size of integer. So now we have told that size is the line counter. So we have said that there are this number of documents and inside the length array there are 10, for example, a number of different length sizes. So after for int I equals 0, size I++, and inside we initialize its document, its string with a proper size. So documents of I equals car star malloc buffer size of car. Now we have allocated the appropriate memory for each part of the document. For each document, excuse me, not each part, for each document. And all the document array and all the lengths array. After, we want to be sure, yes, we want to be sure that my map, when it is destroyed, as you can see here, when it is my map is destroyed, we want to be sure that every memory is deallocated in order for us not to have any leaks and to not have any security problems, security and other problems. So the correct way to do that is my map like that, my map for int I equals 0, I minus size I++. We want to free its documents of I. So remember, when you allocate the memory like that, first you allocate the I index, and after each element of the array separately, then you have to deallocate it the reverse way. First you have to deallocate each element of the array and then the whole array. First we deallocate each element, the memory of each element, and after we deallocate the whole array. Free documents and free lengths, like that. So, and what else now? Um, as you can imagine, I don't know why this is still red. Map to date. Sometimes it bugs a little bit, so if I close it and reopen it again, I think it will be fine. Yes, bugs sometimes, guys. Uh, so it is perfect. After, as I told you, every time you have to pass the CPP file to the make file. So here will be map.o. Here will be map.o. Here will be map.o, map.cpp, map.h, like that, -c, map.cpp, and I think it will be perfect. Map.cpp, so change read input, and everything runs smoothly. And inside here, of course, we want to delete my map before we destroy anything. Before we close our program, and then we will check if I will show you a very cool trick, a very cool tool that I use in Linux in order to determine in order to determine if I have any deallocated memory. The tool I use is valgrind. So sudo apt get install valgrind. Valgrind is already the newest version. So, okay, we have already installed Valgrind. So, this is the way Valgrind is used. Valgrind minus leak minus check equal yes. Of course, it has a lot of different arguments that you can use, but I will show you only these. There is a way that you can see every last part of the memory, and it is pretty useful. And so Valgrind minus leak minus check equals yes, and search engine, I think, search engine minus d small dataset.txt, unless how I'm calling it, yeah, search engine, yeah, yeah, I think it's like that. Yeah, okay. Search engine, small dataset txt minus k2, for example. As you can see, I will increase the font a little bit. It says that 15 allocs, 15 frees, so all heap blocks were freed, no leaks are possible. So we have pretty nice memory management till now, at least. We'll use this tool because this is a project that a lot of memory is allocated. We don't want to have memory not deallocated and have leaks, memory leaks. It will be not optimal for our program, since we use a lot of different structs, a lot of memory from the system. So Now we have created the map and we have deleted. We want to read the input, and here we are. We are saying right here, read input my map com argv2, like that, and we go to the read input.h and the read input.cpp, and inside here we will write the read input function. So let's begin. We go to read input. We have the read sizes here, and we go after a little lower, and let's begin. Int read input my map star my map and car star doc file. So we will again open the file because we have checked before. Of course, we have to include inside here the map, and we'll have a conflict later. I will show you. Inside here we have to include the map, include map.h, and here you will see the conflict of make redefinition of class mymap. Because I have used a lot of times, I have used two times the map.h. So I will show you a way that you can achieve this. First of all, let's go here, int read input my map star my map and car star doc file. I think now it will be no problem. So, what is the way how we can achieve that this class will not be redefined? So, look what it is happening. Search engine asks for search engine.h. Search engine.h is here. It's here. It calls the read input.h. Read input.h is here, and it calls the map. When the map is called, look what has happened. It does what it will do, and it goes back here, and the map is called again, and we have a redefinition of the class. So what we can do to avoid that is to add a guard, a definition guard. So we will tell to the map over here if not defined, if not defined, map h, this means map.h, this is how it is written inside here, define map h, and of course here and if. So what we are as you can see, the error will be lost. So we are saying that check your definitions. If map.h has called again, then don't run this part of the program. And so this is how we achieve the functionality given here. And other way to do it is manually check when map it is called and not right, but it's not correct. I prefer this way. This is how it is mainly used. Excuse me. Again, I use a bug here again. Um, so we are inside the read input.cpp. We go here, and now again we will open the file. Um, Excuse me. We'll open the file. We don't want to check it again because we have checked it before that it is correct. No reason. We check it before that it is correct. So inside here we write car star line equals null, size t false buffer. Again we follow the same procedure as before. The lines are buffered. The false buffer is we're saying that we just want to to allocate as much memory to the line till we reach a new line character, and after where we are here in car length, and so now we want to have a temp that this will give um, this will the temp will be used later, but okay, let's not use it right now. Let's just pass the map arguments. Remember that the inside map we have everything needed to achieve um, all the allocations, etc. So for int I equals 0, I minus. Now we're going to go to map.cpp, actually map.h, inside here, map.h, and we want to add some setters and getters. Const, we use const when inside this function called nothing is changed. Just to know from future use that nothing is changed inside the function. Return size. Const int get buffer size, return buffer size, like that. And so we are pretty cool right now. We have the get size and buffer size. We want to go to map.cpp. No, we don't want to go to maps.cpp, and we're going to need input I, because we want to actually it's the same, but let's not have again a while loop. A different way for us to do it is for I minus my map get size I plus plus. I will tell you the reason we are doing this. So we're using the getLine function again, ampersand line. So we give to it the memory location of the line where it starts, also the memory location of the false buffer. False buffer is 0 again. False buffer is 0, and the file that we want to read from. And now we will create the insert function. So let's create the insert function. How the insert function will be. Our protocol will be if the insert function finds a mistake, the program will be closed. So we want to free every part of the memory. We want to free. So the way to do this is if if my map let's create the insert function. Oh, excuse me. Let's create the insert function first. Um, so int insert car star line int I. This is why I used here this form in order to pass the integer I, and inside here where it is read input map.cpp here my excuse me my map insert car, if I remember, car star line int I, like that. And of course this will be integer, I think, int my map insert, and return 1, for example. And inside here the oh, excuse me, it's not here, read input, it's here, get size my map insert we will send it here inside here the line, and also we will send the I line I. If this equals -1, if this equals -1, then we will write document does not meet the requirements and L, and we want to close the file. We want to free the line. We want to free the temp, not the temp, excuse me. Actually, the temp is a variable that we'll use later, but actually let's not write it down right now. Return -1. And so here we are. Perfect. I think we're perfect. Okay. So -1 is returned to the read input. And of course we go here in the input if equals -1, we want to delete my map and return -1. So we have an error. Let's see where the error is. Real log. Okay. Let's find out now where it is. Get line, force buffer, free line. Yeah, this is where the error is. Of course, every time you have to, as before, free the line. You have to line equals null, and false buffer equals 0. And of course you have to close the file, fclose file, and you have to free the temp. So let's check again. Let's check again. 0 errors from 0 context. Perfect. So now we have to create the insert function. So we go to map.h. We have to create our insert function. It's not that difficult at all. So we are map.cpp over here, and let's start. Int car start token. So token equals strtoc line, either a space or a /t. This is a tab. So because we don't have strtoc, we have to have inside here include stdlib. Here we have to have or include the string. Sorry, include cstring. If I remember correctly. Where it is, I think now, yes, it's perfect, no problem. So now if I see out the token, just the token, see out token and del, you will see it will turn all the context, all the numbers. So for now, let's use the small dataset. Small dataset 0, 1, 2, as it should be. Because 0, 1, 2. Okay. Here we are. Moreover, we have the token, so we have to change it car current index. This is the current index, so car is equals a token. After we want to check, because this should be at the advancing order. We want to check if the current index is equal to the advancing I of the I, is equal to the I. So this I, that it is returned from, it is passed from here. So, and car, if it is different from I, then we have a mistake at our document, because the protocol is not followed. Token equals null, free token, return -1. So this is the way to free the memory of this token from strtoc. Because if you free the token, a part of the line will be freed. This is a mistake, of course. After, we want to so we have checked if it is correct, if the input is valid. So after token equals strtoc null, we have said that each token for the next one um, it is divided by a new line character. So this is what we're searching for here. /n. So while token equals, so we want to delete now, to erase all this part. We don't care, because maybe it's like that, maybe it's like that, we don't know. We want to erase all this. So the way for us to do it is that while token 0 equals with spaces, then token plus plus, token plus plus. Now we will have end, okay, so let's go again. Token strtoc minus t, this is past. When we are doing again strtoc with minus s, all this, for example, all this is past. So we want to erase all this from here and from the end, for example, if it is like this, in order to discard any stuff that we don't want to include inside our file. So the way for us to do it, this is it. Int equals 0, while token and different. This is the terminating character. When a -n is found inside the token, when -n is found right here, it is changed from -n with /n. The new line character is changed with /o, which means the null character, the terminated character. And equals 0, while token and different from terminated character, and plus plus. We want to find the end. We go one. When we find the end, we go excuse me. We go one place, one index behind, because we don't want us to be a determinate character, and while the character that we are in, while end difference from 0, of course, and token and equals with space, then token and equals with the terminated character. And after we want to do it again. So I will show to you what we are doing right now. We'll have a token. I will explain to you in a second. So we want to copy all this strcpy, we want to copy all this inside our documents to OVI. We want to pass each token that we are reading, we want to pass to the correct documents. Now we have an allocated array of different documents. So at the index of the array, we want to pass the correct token. This is why we're doing this. strcpy token equals null free token. So let me explain to you what we did right now. Let's say we have a line here, 3, 3, 5 spaces, hello mama, and again like 10 spaces or so. What the So what we're doing here, we raise with this part here, we raise, yes, with this part here, we raise this part, and we have this part again that we want it to be discarded, of course. So with this part here, with this part here, we go, first of all, we find the end. When we find the end, we go one place behind, and when we go, we check. While we are not at the beginning, so you know we don't want to get the segmentation fault. While we are not get where we started, and the token it's a free space, it's a space. Then erase erase the space and go to the previous. So what we're saying is, we are here. If this one is a space, erase the space and go to the previous position, and do this all until you reach a letter, for example. So this is what we are doing with that part over here. So we want to we want, so for example, let's print our what we have done, and so we will the way to do this is go to map.h. After insert, we want to set a get the length. So inside here, read input. Excuse me. The length is very important because we will use it later when we want to define where to underline the words. It will be very important then. For now, where we are at, for now we will write some secondary map functions that will help generally. So void set length int id int length. It will be an inline function, lengths id, this length here. We have allocated the memory before, of course, equals length, like that. Get length, of course, int get length int id. This will return lengths id. Void print int I. This will excuse me. This will print a document for us. I write them down because I think that we may use them later. We most probably will use them. Car star get document. It's more beautiful like that. Get document I return uh, like that. And okay, now let's go to our main program, search engine.cpp, like that. And 4, let's check our map if it is correctly written. 4, read input. Okay, whatever. Um, give me a second. Mm, for int I equals 0, I. Actually, let's erase this. I minus my map get size I plus plus my map print I. So let's make I forgot that. As you can see here, only a space it is written. Nothing it is in the end, no spaces, even though that I created, I think, one with, no, I didn't create, I create, let's create one make again, this one, yes, this one, as you can see, no spaces, it has no spaces, because it is deleted, these are discarded, and so what else? Um, um, uh, at the next video, I think, yes, I think we have finished with that part. At the next video, we will cover the try. For now, we have to cover the try, we have to cover a score list, we have to cover list node, we have to cover the print, the output. We have some major things to cover, I think. And I hope and you will learn a lot through this tutorial, and how you have to manage your manage your system memory, etc., when you're using really memory intensive applications. So bye guys, thank you for your time, and hope see you soon at the next video tutorial. Bye. Hello guys, so at this part of the tutorial I will explain to you what functionality will our program have, and the first command that we want to use to our program is actually, keep in mind, it is the tf command. The tf command is, for example, so we press tf and we press after 0, where we are, here, 0, and after the word that we want, so tf 0 high. So from the 0 document, it tells us how many times the word high exists. If it exists 0, it will say 0 high 0, for example. If here it is 2 and in here, as you can see, there is 1 times. So 0, 2, high 1 it will present to us. We will have also the exit function, the exit, that will close our program. Moreover, that we will have the df that that will have a double functionality. When we use a df alone, it will show all the available words inside the document and how many times they are presented inside all documents and how many times they are presented. If we write df and a word, for example hello, it will tell how many times only the hello word is represented inside our data set, inside all our documents. And finally, we will have the search, which will be our main goal to achieve. We'll have this and a search query, for example, like that, and it will present all it will write down all the documents with decreasing according to an algorithm with decreasing number how relevant this document is with our search query. So these are, and with underlining of the word that we search for, So these are our four excuse me. These are our excuse me. These are our four functions that we'll use, and of course the exit. So in order for us to achieve this, let's say, we will create the try. The try is pretty important, and what is this all about is managing to it is the try will have, I will explain to you right now what the try is. So let me open a board, online board. Okay, I will use a simple online board right here, like that over here. So let's us have the word start. After we have the word, I hope you can see like that better. We have the word stop, and we have the word sing, and we have the word, for example, ship. And let's I use now we have a different word too, for example. So this is how let's start from the beginning. This is the try. This tutorial right now will explain how the try works. So okay, the try is accompanied with a list. If a list is present, so S, and here we have a list. If the list is null, means that there is no word that is only S. There is no word that contains only the letter S. So null. So we go like here. T. After we go like that. Of course this is null again. I will write just n. Excuse me, like that. Uh, just n when it is null. So a like that, again n, r, and t. So for stop, for t there is, excuse me, there is a word. So we write down the document that it is present. We write down the document here. Document. For example, it is 12 document. For example, it is the fifth word. For example, we write it down. For example, 12.5. The stop, we go here, we go O. Stop, we go O right here, and of course there is no with that. We go P, and there is. So we write down again. After, this is what we will call a list node. This is a list node. This is a list because there will be multiple starts. So again, if a start is present here in the document 10.3, means document 10 and as a word 3, we'll have a different document again right here. So this is a list, and each node of it will be called list node. So stop right here. Inside the stop will write. If a sing is called, we'll have I right here. And of course we'll have n right here will be of course again n. Actually zip is no reason. Actually I'll write down zip again, and g for g there is a document to be written. So after that h I and P there is, and P there is, and if we have a 2, with these two will be connected as brothers, and let's say will be a higher list node which will be empty, but no reason for that. These two will be connected as brothers, and right here will be 2, and after will be O, here will be N of course, and here will be O, will be write down the document. This is what a try is. So in order for us to search for a word, tell me if the word stopping exists. We search from S. We go to T. Here, H is not correct, T is correct. We go to O. We go to P. After, all its brothers are null. So no words can be existed from derived from stop, as stopping, stopped, etc. So this word does not exist. Now let's search again for a word from another word. For example, let's say again for word sin, amartia, sin, yes. We go here. Give me a second. scene. Um, let's search for the word scene. If a scene it is correct, it is found anywhere. Go to S, we go to I, we go to N. The word that we found is found inside the try, but the list node is empty. Here is empty. The list is empty. So no, there is no document that contains this word. So neither this word exists. So let's now check for the word ship. S here, H here, I here, P. There is a node over here. So as you can imagine, this um, uh, so as you can imagine, the the search it is correct. So there is a word as ship because when we managed to find it inside the try, its list wasn't empty. So guys, as you just saw, this is what try is. You can pause the video, re-see it again, and it is very, very, very fast. Now, we will try to actually let me check for a second if we can connect it somehow with what we want to do. Um, Actually, guys, I think there is no reason to write down the try right now. We will write it at the next video tutorial. I think it's better for your understanding to see again the video. So guys, thank you for your time. I see you at the next video tutorial. Um, so bye guys, see you at the next. Hello guys, at this part of the tutorial we will try and create our try. So let's wait till here we are. We will open the VM again. I explained at the previous video what a try exactly is. I hope I have helped a lot. You can check it again if you wanted to. And let's open the VM. Okay, it is opened. Okay, here we are. We go inside the search engine. Open with other application, Visual Studio Code, select, and we will open the whole folder using Visual Studio Code, of course. And here we are, the search engine input map and all everything that we want to use. So let's try and create our try. The way to create our try, I think it will be the same as I told you before, and slowly we will add some functionality to it in order to use the try to search words, etc. With different search methods, you will see. Um, so so we have to create a new file here. Actually, before the map, let's say, and a new file again. The first file will be called trynode.h trynode.cpp. So here we are, trynode.h trynode.cpp, and while we have this, first of all, inside .h we have to include IOStream as always. Furthermore, excuse me, we have to include here we have to include trynode.h over here, and include let's say stdlib right here, because we will use some malloc. Include string as well, and because a lot of different CPP files will need the try node in order to function properly, we will add guard and like that. And inside here we will have the try node. If you remember how the try was written, we'll have a try node. We'll have a node, for example. The way we will do this is it is like that. Give me a second. I will show you online whiteboard. In order to avoid an array where everything is connected, for example, S, T, H, for example, start, shop, and sibling, for example. In order to avoid this, to have an array inside the try node which will show other try nodes, I think it is better to have a pointer to the first child that it is shown to us that we have written. For example, if we have the word start, shop, and sibling, and the first letter was start, so T will be the first letter from our children try nodes. So T, and T then will be connected with H and I as brothers, as siblings. And each one of these will have, for the example, A here, we have O, for example, and we'll have B here. As you can imagine, I think this is the better way to do this because we have to reallocate memory to the array every time we find the new world, or we have to allocate 24 or a static array which will get memory that we will never use. So it is wrong. So let's from here close this. Actually, let's. Alright, so here we are inside the VM and class try node. Like that, and of course we have to like that, perfect. Try node star sibling will be its brother. Try node star child, its first child, and we will have a list here. Here will be list node, of course. Okay, so let's now, the list node is what I explained to you at the previous session, is for example, here it will be null, here will be null, here will be null if we have t, r, excuse me, and after that we'll have a t over here. This will have a list node that will identify. It will have a list. Each list will have the list will be actually will have a lot of nodes, list nodes, and if a list item, its node, will have specifications about where we can find this word, at what document. For each time we have found this word will be a different here. Will be, for example, we have found it in 3 different documents. We will have 3 list nodes about where the word is inside these documents. So here will be the list node. So let us now have actually why we can create the list node. It will be, you know, actually we can create it later. No reason to do this now. So, and of course it will have a value, car value. It will be a letter. Public try node, the destructor try node, like that, and of course we will create the insert, and later we will create a search word, search all, etc. For each different function we will create a different search type for the try node. So first of all, let's in order to delete the try node, what we will do in order to create it, we go to the try node inside here and we go like that, try node, value -1, in order to know which values are being initialized or not. So the sibling will be equals to null. This is not necessary, but in order to be sure that it will not show to a memory that it's not null, we will use null for that. So null. The list will be null later, so I will do this right now. Actually, let's go here and show you how we will write this. List node as write list. this will be right like that. And so here we are. List perfect. So now we have created the constructor, and now we will create the destructor. The destructor in order for to deallocate all the memory that has been allocated, of course. So the way to do this, it's recursively. Um, so um, try node if so this will be, of course, if we have a list. So what this does is that it will delete each element and each element of all lists. This will call the destructor of the list of the list object of the list class. So if again with following the same principle of recursively deleting, if child different to null, delete child, and after if sibling different to null, delete sibling. So we have created the destructor, the constructor of the try. Now we want to add the try inside read input. We have created the guard here, so include try node.h. Here we want to add it over here as well. We want as well to initialize the try here. Search engine, where it is, search engine.cpp, where we have created a map here. We want to create our try as well. Try node star try equals new try node. So now we have initialized the try. Yes, with an empty node, of course. And so what else? Inside now the read input, we have to initialize the try as well, of course. So the way for us to do so is pretty simple. So first of all, inside the make file, it is better for us to write now I made a mistake again. Rename, no, it doesn't have a rename, so I have to do it myself. Because it is a class, it is better to have it written like that, with caps lock. It is not that good to write it. So let me close this, and close this, and go here, and try node rename, yes, and rename like that, of course. Okay, I will close this, and I will reopen them again. like that. Perfect. Okay, here we are. Read input dates. Here we are. We want to pass the try as well in order to initialize it and pass all the values inside the try. It is very, very important. So for us to do so, um, it's pretty simple, I think. Um, First of all, you have to pass the try inside here. You have to go to read input.date, try node star try, like that. Read input.cpp, read input try node star try, like that. Try node star try, and here we will pass the try. What we will do now, first of all, because we pass inside the document each line, if we want to destroy this line, we cannot, because if we have a line with 1000 words, the try will str-talk these words in order to take each word alone and map it inside the try. So in order for us to do so, we need a temp value, car star temp equals car star malloc my map get buffer size of car. Size of car is 1, but just to know, we use size of car because in the future, in a very long future, maybe it is like 2 letters, not 1 letter, 2 bytes, not 1 byte. But yes, this is why I use this, in order for our program to be always used without any problem. So get line, insert, of course we want to free the temp here if there is a problem, and here as well we want to free temp, like that and like that. And I forgot, here we want to return 1 every time. It is correctly. So now we will call a different function. This function will be called split, I think, will be pretty okay to be called like that, which will, its job will be to split each individual word and pass it to the try in order to, for the try to do the job, for the try to do the mapping. So, so the way to do this, it's actually pretty simple. We want to, inside here, we get buffer size is the longest line ever inside the document, so temp will be always fine. So str cpy temp my map get document of I. If you remember, we get the document and we don't get the line because there is no reason to get the line. Because if we get the line, then we have to again destroy the first part, and it will be actually we will do some work that we have done before. So we use the get document, so we'll get only the useful part. For example, we'll get only this, not with that as well. So this is useful, the useful part. And in order to have the information about which document is, we will pass an integer with it inside the split function. Pretty simple, right? So here we have a split. We will call the split function. split, which actually the information that we want to use is our temp, of course, our temp string, our integer, our try, and our map. I will tell you later why we use the map. We use the map in order to tell to the map how many words are inside our document. You will see in a second. Um, so here we will create our split. Excuse me. Void split. Car star temp int id try node try and my map. After that we will do this, and it's pretty simple right now what we will do. So car star token equals str toc temp. So we have a word right now. The token shows, for example, here at I shows, or at age, for example. Token 0 is at age. So we have int I equals 0, while token different to null, I++, try insert. In order to have the correct insertion, in order to know, in order to have the correct insertion, we have to pass the token, and the token, of course, the word, and at what document it is shown. So token ID token equals str toc null, like that. We will write the insert later. So my map set length, if I remember correct, the ID of the current document that we are passing the tokens, and the length of it, which the length will be the I, will be the counter, the I, because every time, so what does that do? Token shows here. So every time we see a space, it goes to the next G, how, R, U, I, ho, etc., 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 till it ends. It's fine. When it ends, each time we do str toc, this is what is done. So when we have finished our line, token will be null. So this will break. Of course, we have to free the token right here, and we have insert here token ID. So now what we have to do is to create the insert function. So let's go here. We'll have an insert function doesn't need to return anything. Void insert car star token int ID, like that. And inside here at the insert function, we have to go to here, and we will insert recursively again. It is the best way when we use a try to insert recursively. So void try node insert car star token int ID. So Uh, so now we want to check if the current value is here. As you can see, we have passed it. If the current value is -1, that means that the new node is not initialized. So what we are going to do right now is if value equals -1, or we have the same value as the token. Our token has the same value as us. Pretty simple, right? So here we are. So what we are doing right now is it is the moment that we want to install inside our try the word shuriken. S has the same value as S, so it will go inside S, inside here. So anyway, because we want to cover the when token is not is -1, if strlen of token equals 1, this means that we are the final letter. Then we want to initialize a list. Initialize list. Else we do the same thing with the children. If child equals null, child, we want to go to the next try node, because for example here at this right here there is a problem. We have the S, and here then we have to pass this word. We go here and we want to insert u inside here. We check if the child is null. If it is null, if the tree was like that, it will be null. Then we want to initialize the new node right here. So this is what we are doing right now. We're initializing the new node, new try node, child, and we will recall recursively the insert function token +1, because we want to, because we have just passed the S inside. Now we want to pass the U. And the ID, of course, of the article, it is not changed. Now if we don't have the same value, first we want to check. As you can imagine, we want actually this is no reason. Okay, return anyway. Right, we want to check if there are any siblings. So at this here, U is not T, right? Right, is not A. We want to check if there is any sibling, because maybe the word super was present and U there was in the list. So we want to check all the brothers to check if there is U, and if it is not, then we'll create a new node called U. So else, if sibling equals null, then sibling equals new try node, and sibling insert token ID. So we have just finished our try node. we need now to create our list node in order for us to be perfect. To where it is, insert now. Of course, I have to close it again. Everything is passed right now. Try not to take. Now we want to create our list node. The list node will have some important stuff inside. First of all, I forgot to make the make file here. Try node.o. Here we will have to add try node.o. Here we will have to add try node.o, try node.cpp, try node.h. Here we are. And of course, open terminal, cd desktop here. Actually, let's zoom in a bit in order for you to be easier. Like that, perfect. And we'll have here, we always on top. And if I press make, try node.cpp here, because this should be in headers. Everything is made beautifully. So now let's create the list node. The list node, it's very important. Actually, let's make a revision of what insert is doing right here. So checks if the current value of the node is uninitialized or we have the same value. If we have the same value as initialized, then go in. Now, pass your value, okay, to the current node, because if it has the same, nothing will be changed. If it's -1, we will initialize it. Now check if your word is too small. It's the final letter, and if it is a final letter, this means that is the word, and we have to pass to the list the information about where our word is. So here we will initialize the list. Else, different, if we are, for example, the third letter of a 5-letter word, the third letter of a 5-letter word, then we go else. We will check if there are children. If there are, then we will insert, we will do recursively and check again all these. Else we will create a new child and initialized, and we'll go here as previous. And so let's say that our value is not the same, or the value is not initialized at the tree node. Then we want to check if there are siblings, if there are other brothers, like that. If there are other brothers, if there aren't, then we will create a new one. If there are, then we will check all of them. If we find what we are looking for, that it is okay, and we will continue our function recursively. If we don't find, we create again a new one. It is pretty simple. It's not that difficult, I think. So now I suggest we go to create our tree node, our tree nodes class. So let's create our list node. Actually, again here, read input. Give me a second. Excuse me. CPP insert. I don't think we will use anymore the read input.cpp. We have insert. We have done anything that we want according to the input. I don't think we have anything more to address here. So I will close these two. Also, I think the map is finished, so I will close the map as well. Maybe we will address the map later, but I don't think so. I think we have just finished. And now we will go to the search engine. We will create the excuse me, not the search engine. We will go to create two new no, excuse me. We will create two new files, listnode.h, excuse me, here, and list. Perfect. Inside the list node.h we will include the all here. So also here inside the try node we want to include list node.h. Perfect. And what else? List node.cpp, list node.h. So inside here we will have the class of the list node. How I managed to do this. So we'll have the class of the list node, and here will be the list node.cpp. Inside here will be this. So it will be a list, as you can imagine. So it will be connected with 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 a pointer to the next node. And what else? Furthermore, we want to have inside, want to have two different things. We want to have the item, the ID of the document ID, and how many times. So it's list node. It's about a word. Okay. So at the end of T, there is a list node right here. Wait, let me show you. At the end of T right here, there is a list where so it explains where the word start is presented. It says, for example, start is presented 5 times at document 5, 3 times at document 2, etc. So if we have a list node for our small dataset over here for, let's say for all the words, hello will be presented at document 0 like 10 times. I don't know how many times it is written. Hi, it is written 1 time at document 2, etc. This is how it will be written inside the list node. So inside here, list node int document ID document ID times 0 next equals null. This will be the constructor, so this will be public like that, excuse me, and inside will be the ID of the document. How many times to each document to the specific doc. So perfect. We have created our constructor. Wait a moment. We will have the destructor. The destructor will be a little bit more complicated. List node.cpp up here. We want to include, as always, include if next different to null. We will again delete it recursively, as you can see. Delete next. Perfect. So what else? I think what else? I think now we want to create the add function. So void list node add int document ID. If document ID that is given here equals with the ID of the document of the list equals ID, then times plus plus. Why though? List node has no member. Include list node.h, list node.h. So if I erase it and reopen it again, has no member add. That's why I forgot to have it right here. It would be a void, I think, void add int the ID like that. Class list node. Of course we want to pass the guard. If not def, list node h, hashtag define list node h, and if. So here we are, the search engine. I don't know why. There's no member list node. Okay, now no problem. It was a bug, a minor bug. So you have to just to restart it when something like that happens. And so if the current document ID equals with the ID that the word we are looking for is given with us, then we want to increase the time. Else we want to check at the next. Then we want to check if the next is null. If the next list node is null, then we want to create new next equals new list node the ID, like that. And next add the ID. So it is pretty simple. What we're doing right now, it's actually pretty simple. So every time for example, let's say we are right here and start the list node. It's this document document 5 three times connected with the next document is document 7 two times and document 9 one time. So let's say we are at document 10 and we just read the word start. We will check, is our the document 10 has the same as 5? No. 7? No. 9? No. So we will create a new one. This is what this line here does. It creates a new one, and then we will add the current document ID, which means 10. When we add it, because we have initialized it here, when we add it, then this is what happens. 10, 0. Then we call the add function. This is when we call the list node, new list node. When we call the add, again, excuse me, then 0 becomes 1. So let's say the second time we read again a start. It goes 5, 7, no, 9, no, 10, yes. So 1 becomes 2, etc. This is how our list node add the function works. It's pretty simple, I think. So now let's first of all make list node is not added to the make file, I think. List node.o list node.o list node.o list node.cpp list node.h like that, -c list node.cpp. Perfect. Let's make that right now. Everything runs smoothly. Where we are at now, search engine. So we have just, I think, we have just finished creating our try, and now actually we don't have a lot of things to do anymore. We have I think 2 structs, a score list and max heap, that will address at the end of our tutorial. And so we have some pretty important stuff to do to the try node and to the list node as well, and you will find out soon enough. And what else? So at the time, so I think let's run search engine. Perfect, it runs perfect, but let's like that. Of course we want to delete the try right here. And I want to run the val grind function in order for us to be sure that everything runs smoothly. 0, all heap blocks were freed, no leaks are possible. Everything was smoothly created. So for the purposes of our first of all we will write right here database ready, because our database is ready, and we have passed our try. We have here read input.cpp. We have everything runs smoothly. And now we will add like pretty fast. We will just write a simple input and exit, nothing more. So while one get line, we will right here we will call car star input equals null. As you remember, we'll use the getLine function. Size t, input length equals 0. GetLine, where we are, I lost ampersand, input length, and std in. We want to read from the from the keyboard right now. So I will write a pretty stupid if exit is given, then it will return exit. So the way to do so, actually, let us do it at the next video tutorial, because this video is already pretty long. So it's about the try in the list node, so it's about the try, and I don't want to spoil it with some input stuff inside it. We will do it at the next video tutorial. So guys, thank you for your time. I hope you had fun, and see you at the next videos. Bye. Hello guys, at this part of the tutorial we will try to create a basic input manager. So the input manager would be like getLine int return value equals input manager input try my map and k. If the return value equals -1, then cout wrong input, and else if red equals 2, that means it's exit. Exit is called, so free input and break like that here. Every time we want to free in the input, and we want also to put input length to 0 as well. So now we want to write our input manager function. Inside here, up there, we will have int input manager car star input try node star try, and my map star my map, because it will redirect to different functions that will use them in order to achieve the search functions. So now we will take each word of the input in order to understand what is going on. So car star token equals str talk input space or ni. These are the delimiters. So using them we will take every possible scenario. So now we want to create um, a new file which will be called search.cpp, and inside there we will have all of our functions. Um, so uh, let's create it right now. And here we are, perfect. Of course we want to include some basic stuff inside here. Um, of course we want to include, later we will include what we want. Inside here we will have three major functions, as I imagine: the search, the df and tf function. Contain the token try node start try. Also we want to include inside here, include try node, and include map.h. My map star map and the number of results that we want to be shown. And after we want to have void df function, we'll have try node star try, and int df function we'll have car start token excuse me, car start token, and try node start try, like that. So what else? So we want to go inside here. We want to include search.h inside here. We want to have a void search function. And the void search function inside here. No, excuse me, void search function. Have car start token. Try node start try. My map star map and int k, and we'll write cout not implemented yet. Yes. Like that. So we are perfect. Just using namespace std, cout not implemented yet. And now we'll have again the same. And finally we will have the TF, which will have car star, excuse me for a second, car star token, and try node star try, YTF is be an int, I think. And again the same. So see out not implemented yet. So we go to the input manager over here, and we want to check if everything it's given correctly. So we are here. If strcmp token search token try map and k. Else if we want to include inside search engine.h, we want to include search, include search.h. We want to include map is included actually. Yeah, it's better like that. Else if strcmp token else if strcmp token about the tf function here, tf, and if tf token and try equals -1, turn -1. So now if exit is called, and return -1. Else I was thinking now about when to free the token, but I have freed it here, as you can see over here. If rent wrong input and it is freed, so no problem. So else else if strcmp token exit cout exiting token equals null free token return to and else return -1 and token equals null free token return 1. So everything is correctly written, I think, except this one, the TF token, that I want to write a little bit better, because everything is controlled and the search query is right, but we want to check it a little bit further. So let me first of all pass it to the make file, the search search.o like that. Perfect. And now we will run the make file again. Desktop, open terminal. Using before expect initialize before using declaring the scope search tf now it's int tf. Why though? And search engine using namespace std, but the problem is that we have used it here. Expect initializer before using. Why though? Initializer before using space std. This is not wrong. And in function tf was not declaring the scope. Tf token try df, and if you go to search.h, tf is called right there and tf is right there. Search.h, if using space std like that. include search.h, search.h, search.cpp, search.h. Yeah, my bad there. Everything runs smoothly, and if I write these, search hello, not implemented yet, df, tf, and exiting. So let's run the val grind, tf, df, search, exit, no leaks, perfect. So now let's fix very fast because inside here tf needs some more checks, so we need to check it up before we finish. It's like 10 lines of code. So every when token when we use strdoc, it is globally implemented, not locally. So that's why we can use some pretty cool stuff. So we have car star token 2, and use token 2 equals strtoc from null from the previous function, which is right here. We have used strtoc of the input, and we will get the rest of the input using this. Null minus t minus n slash slash c slash n, and if token 2 equals null equals to null, then free token 2 and return -1, and we want to check if token 2, if now that the token 2 is empty, if it is a number that it's given. So for int l equals 0, l smaller strlen token 2 strlen token 2 l plus plus, if is digit token 2 of L, so if the first word is not a number, so token 2 equals null, again free token 2, return -1. So perfect. And now int id equals atoy, because now we know it's a number, atoy token 2. We want to strtoc one more time to check if there is a second word. If token 2 equals null, free token 2, return -1. And now we will check if everything is correct with /tf. If you remember how what tf is about, I will explain to you in a second. Make, so after val grind, and now we are saying like tf DD, which is wrong, but TF2D it's correct. TF2 it's not correct, but yeah, I forgot to strtalk here. Token 2 equals strtalk null space tn. Right now TF2D correct, but TF2 it's not. TF2 it's correct. TF without a number it's wrong. TF without a number at all it's wrong. So DF is correct, search is correct. So perfect. I forgot to exit. TF2D, TF22, perfect. TF empty. TFD, D, TFD, TF2, perfect. Exit. No, no unallocated memory. Perfect. So what else? I think this is what I wanted to show you pretty fast. Um, so guys, we just implemented a basic input manager. So I hope you see at the next video we will start to implement all the search functions. First we will implement TF and DF, and lastly we will implement the search function at the last video, which will be very interesting. So guys, thank you for your time. See you at the next video. Bye. Hello guys, so now we'll start to give some functionality. We'll start to give some functionality to our search engine. Um, so let's begin. Writing our secondary search, types. TF search, DF search, and after we will try to. At this video we will cover DF search. At the next video we will cover TF search, and at the last video we will cover. And the last video we will cover. We'll cover the search here. So let's begin with let's say TF search. As you can see, we have write the most code yet. So let's begin. What TF does is takes the token from here. So if for example it's TF Nikos, will show at which document how many times there are of a word. So the way to do so is pretty simple. We will write down first it's the ID, so we'll see out the ID. After we'll have a space. After we'll have token 2 as the word will be given, and after we will see out the result of a function which we will call TF search word function, which it will be a try function from the try. And inside here, in order to find out at which specific document how many times a word is given. This is what we will write down. We need to know the ID, we need to know the word, and we need to know at which index of the word we are, in order for us, um, in order to count down how many, not index, in order to count down the number. Give me a second. 1 second, please. Uh, yes. So here, so we go to the try, where it is try node.h. First of all, we need to um, try node.h. Inside here, um, we will write the type of what the function. So int tf search word int id car star word int car. And as I told you before, let me explain to you one more time. Inside here, um, this will return this function here. We will return an integer that will explain to us, will show us how many times a specific word is given at the document, specific document. Um, so remember, guys, before, all the structs that we created was just to achieve a very fast response times. This is why we used all the structs we have used, the mapping and the try node. This is how probably how search engines work for that data that are really frequently used. Um, so um, now let's write the TF search word. Um, uh, so let's go to the try node.cpp. Here we are. Let's move it here. We don't know. Okay. Int try node tf search word int id car star word int current. If word of current index, this number that we gave here is where we start. We start at the zero index, index 0. So the current now is 0, equals with value of this try node. If car equals strlen, this mean -1, of course. That means that the words are exactly the same. So what we will do now is we check if the list equals to none, null. If they are not equal, I have forgotten to initialize the list here. Excuse me, I forgot to write the list here. Also, I've forgotten to initialize the list at the insert function. Here, if list equals null, list equals new list node id list add id. So now we have to go to the try node.h and add the list node like that. Everything runs perfectly right now. So after we have to go to tf search word if list different to null return list search. The list search with a specific ID. List search, so what will do is it will run down through the list in order to find how many times a word is given at a specific document. For example, it will check all the document IDs of the list, of this list for a specific word, of course, because you know each list is a specific is about a specific word. Else, it means that this word is not given anywhere, so return 0. Now, we have to to write the search, and actually let's write down the rest of the code in order for us to have a continuation to our thought. If child different to null. Now, if we don't have, if the word is not strlen word -1, this means that we have to go to a child. Search word id word car +1. That we will move to the next index. Else, excuse me, return 0. And perfect. So now, if we don't have the same value at the the current character doesn't have the same value as our word character, we want to check for siblings in order if we find anything. In sibling different to null, return sibling tf search word id word and current, because we want to check at the same index. Else, return 0. Because that means that there is no word such as what we want to check. Let me do a demonstration for you, please. Here we are. S T O H etc. From now we don't care. It goes to S. The word we want to check is start, if it exists. It go to S, it go to T, and it go down here, and we will find start if the letters exist. But if we want to check school, it go to S, it go to T, but T is not doesn't have the same value as here. So we will check the sibling. So here we are. O, again the sibling H. If no siblings have the same value, then we will turn 0, because we know that the word will not be found anywhere. This is very important, how search works inside the list, inside a try, because the same principle we will use at the next search functions. So, for example, if here we want to check about here, there is I, and here there is P, and here there is a, a list nodes, a list about where it is found. If we want to check about the word shipping, or shipped better because it is smaller, shipped, it will go here, it will check the shipping, it found the H, it go to I, it go to P. Now it will check if there is any children. The children, there aren't any children, so the word is not found anywhere, so as a result it will return 0 over here. This is what the principle of TF search is, So, from now on, we'll try to create, inside our list node, we'll create the search. We have created the add, I think, if I remember correctly. Yes, now we'll create int search int the ID. We'll go here, and here we will create the search. It is pretty simple. Void, actually integers, no, sorry, list node search int the ID. If the current document ID, which the ID equals with the ID of the list node, then return times. Else, because if you remember correctly, every time we find a new at the same give me a second to explain it as the best of I can. Each time we find the word the same document, we add the times parameter, the times variable. So it will return times, else it will check if there is next. If next is not null, return 0, else if it is null, that means we haven't find a document ID as this the same as ours, so there is no words at the current document. Else it will return it will do recursively the same operation for the next part. Return next search the ID with the document ID given. So this is a search, and now let's compile it. I think it should open in terminal. Runs perfectly. The set ready. The way, if you remember the correct way to write tf, for example, 0 hello, and it says at the document 0 hello is written 2 times. Let's check it out. A small data set at document 0 hello here, and then hello is stuck with fun, so it's not taken as a single word. Let's check at here at 2. If I write again boys right here, what will run? So we have to close it because we have changed. We don't have to make it. My mistake. And tf 2 and boys. Boys is given 2 times. If we give something that does not exist, tf 6, a document that does not exist, did, for example, 6 did 0. If we give tf at the third document, hi it does not exist, and if we exit, exiting perfect. Excuse me guys, I'm a little bit sick. So we just created the TF function, and at the next video we will create our um, our DF function. So see you there guys, bye. Hello guys, so at this part of the tutorial we will create functionality, a search functionality, where we will give, excuse me, this is from the project, where we'll give, wait a moment, we give slash df, and when we give this command, then right now, excuse me, let's make it again. Slash df, it's not implemented right now. Such df 0 high is implemented, so we will implement the df function. So when we give slash df, it will return to us all every word that is presented, every distinct word that is presented inside our document, and how many times we have seen this word, the volume. And slash df a word will return just one word only. So let's close it, and let's go right now to the input manager. Here we are. This one will have you zoom in, but we will make it pretty small. Close it. Excuse me. So TF is implemented. Let's go to DF. We call DF try, and if a pretty cool trick that you can do if you have Visual Studio Code, you can press Control up on top of a function. It will guide you immediately to the appropriate window, to appropriate file, excuse me, at the appropriate place. So now we have the df function, and now what we will do, we will check if a second word is given. If a second word is given, then we will check this word. Else, if a second word is not given, we'll check just for a specific word. So we'll either, or if not another word is given, then it means that the person wants to search for all the words inside our documents. So we'll print every word and how many times we saw them inside our document. So let's begin to write car star token 2 token 2 equals str toc null space n. So if token 2 different from null, that means a word is given to us. So cout token 2 try this search word will be a specific word, this search word 0 and L. So what this does here is it searches for a specific word and and it prints us how many times it returned to us. Excuse me, talking to. And it prints how many times has shown this word in all the documents. So we go to the try.h, we will have integer this search word, car star token, word actually, I think it's a better, I think it's a better word and current, the current index that we are in. So we go to the CPP folder and we follow. So int try node, this search word, car star word, int current, if word current equals value if car equals strlen of the word -1, that means that we have reached the length of the word. We check if there is a list. Again, guys, we follow the same principle as before. And now we return a function from list, which we call list volume, which means how many times a specific word is given. Else, if there is no list, return 0. So we have to go to the list, like that, here, the list node, over here, and we have to create the function int volume, which its job will be just to return how many times how many documents the word is in. So here we are, int list node. We create this function because they will be useful later when we try to create our algorithm in order to sort our results at the main search function. If next return 1 plus next volume, else return 1. So what we're doing right now, every time we do it recursively. So we check if the next is different to null. If the next equals to null, then we'll just return 1. That means that the current document we have 1. If the next is not null, then we add 1 and we add whatever the next the volume will add later. So if there are 3 in front, we will add 3 different lists. That means 3 different documents that are in our function. So where it is. Try not to date. Here I think it should be. Now we haven't checked about the child again. We have to follow the same principles as before. Else if sibling, if child, excuse me, first, if child different to null, return child the search word car plus 1, else return 0. So guys, we're following the same principle as at the previous. As you can check the previous video in order to understand if you haven't. Else if sibling different to null, return sibling, excuse me, the search word current. Again, this is we cover the case that we don't have the same word, so we don't want to check all the siblings for possible and not the siblings. So let's take a look. I think now it will be fine. Search df hello hi. If we check inside our small dataset, hi is only present in 1, hello will be present in 2. So if I say df hello, 2 is presented. If I go exit, let's check it with valgrind for a moment. Valgrind tf yes, tf 0 hello, okay. df hi 1, df ho 0, df hello 2. If I go exit, 0 errors from 0 context. That means we don't have any problems related to excuse me, we don't have any problems related to the to memory management. Even though we have a really big project, we don't have any problems. So let's go now and implement the search all function. This will be a little bit different, a little bit more difficult. You will understand right now. Actually, it's not that difficult, but it's different from this one. So, int actually void will be that, because we will not return something. Void this search all car star buffer int current. So first let's build up the front end. Excuse me. And now let's go to the front end again, not here. Set to CPP here, and here we are. Else car star buffer. Guys, at the final product, when we reach the final product, I will give you a version where I have written a lot of comments in order for you to, when you download it, to understand better what is going on. Car star malloc 256, size of car, try this search all, so we call the search all function, and now we'll go to write it. Try node. So let's start writing it. It will not be that big. So let me go again here. Online board. Online board. So we have this try. Give me a second to color it. Empty. This is supposed to be an M. And MB embed. Here we are. These are the words. And another word will be, for example, EMP. EMP, you know, EMP is a type of it's electromagnetic pulse. So EMP, like that here. This symbol here, over here, means that there is a list. A list is present. Even not even a symbol is not present, like that, it means is null. The list is null. So what our algorithm will do, we'll go to S first. We'll check if it has a list. If it has it has not a list, we'll go to its children. We will have a buffer, okay? A buffer here. First of all, buffer will be equal to S. I will add the buffer down here like that. S will go to its child, T first of all. So buffer will be converted to ST. It has a list. It does not have a list, T. So it will go to A. STA. Does the A has a list? No. We'll go to R, we'll go to T, and this is what will look like. Start. Start has a list. Start. So we'll print out the word start. The start with the volume of start, how many times it is actually in how many documents it is present. So after that, we'll go recursively behind R, A, T, T. After T, we will check every time if it has a sibling. Doesn't have a sibling, R doesn't have A doesn't have it has a sibling, has O. So we delete A and we replace it with O. O doesn't have a child, yes. It goes to P. P has a list, it prints out stop, etc. It goes up, it goes it does the same over here. Over here it's done all the time the same. So we go up again here. E S is destroyed because S doesn't have a sibling after ship is printed, and E goes down. M and P. P has a list E and P. After a T, Y, and so goes on. So this is how our algorithm will walk around. Will work. Excuse me. So let's write it down. Buffer current will equal to value if list different to null, which that means the item has a list, then we want to cout buffer list volume and then del. After we have printed the word, we will check for its children. If child different to null, child, we call the dsearch all function recursively. Buffer, but now the current will be car plus 1 index. Because as I showed you before, we will go to the next letter. And finally, if sibling different to null, sibling excuse me, the search all buffer, excuse me, and current. And this is very important to understand. So when we haven't found anything, we want the buffer, the current buffer, to set the delimiter to the current buffer. The reason we do this is because we don't want to have values such as, let's say we have start. When everything is we have start. When we go back, we have to delete T, R, A, T, etc. When we go back, in order for us to delete it, we replace them with a /0. So the way for us to do this is buff car equals /0, which is the null character. So let me for a moment. So if I want to explain to you something else. I don't think I want to show you something else. And now let's check it out how it works. Let's have it a little bigger. Make Valgrind. So df, if I press df, you can see every single word so is shown at in how many documents is used. And and yeah, this tutorial, etc. As you can see, this stru I is used in two documents. Let's check it out right now. I, one document and two documents. So everything works like a charm. Um, let's do some more df, for example, games 1, df mama 1, df structs 1, df b 1. So now if instead of this we import the big data set, um, what is the name? I think big dataset.txt. Please wait, it needs some time to initialize because Valgrind is called, and because the big dataset it's too big. It's really big. It has like 3000 different documents, and the lines are like um, uh, with 5000, 6000 lines, characters. So let's wait after the initialization. Well, it takes too much time. Yes, perfectly. Database is ready. So now let's check. For example, now you will see how fast it is though. df. As you can see, how much time it took to initialize the. This is why we're using so fast. So excuse me. We use so fast. Um, structs, and we don't check from the document. As you can see, 10 seconds, like 10-15 seconds when we initialize big data set using Valgrind. Of course, if we raise it, Valgrind slows down the read and write from files, and generally slows down a lot of stuff because it reads the memory and checks the memory constantly. So this is the reason. It's much more slower using Valgrind. Even now, you can see how fast we checked all the words from all the documents, how many times are used. Now, for example, if we check for a word, let's go a little further. For example, Q or QWERTY. If we check for QWERTY, df QWERTY, I think none. If we check though to QWERTY, I saw wrong maybe. Yes, I made a mistake, excuse me. As you can see, everything that is shown here, it is shown here as well. So we used all these functions. I created some simple functions now, and at the last part of the tutorial, we will create the main functionality of our search. It will be not too difficult, but it will have some difficulty into it, and it will add two more structs, a score list, and a max heap. I will learn you what max heap is and what how it works. So guys, I hope I see you soon at the next tutorial. So at the next video, excuse me. So thank you for your time. See you soon. Now guys, we will implement the last functionality of our search function. It is the biggest. First of all, the let's say the query will only be able to have at max 10 words. And as I told you before, each word will contain uh, um, for each word a, a logarithm will count which documents are the best. So let's begin. Car word array 10, 20, 50, 6, double, IDF, 10 for each word. And now token strtoc null, excuse me, like that, and int I give me a second. Excuse me, for int I now we want to check for every word, but if the token equals to null, that means less than 10 words are given. So break right here, strcby array token. We want to pass each word to the 10 first words, or the first words to the word array. After we will write the algorithm down, IDF for its for each word, log 10. I want to include cmath. No answer, yes. Now where is the map? Map.cpp.h get size. We have the get size here because we will need it. So we have to cast it to double. Double map get size and minus double try this search word array of I 0. Remember guys, this is just the logarithm, nothing more. And so nothing really important to know over here. You can write your own logarithm, it's nothing too special. And we will divide whole this. What you can take from that is that you have always to, in order, when you have two integers, if you want to add or to add from it or to it, and you want to use it as double, you have to cast them first. This is already double, so you don't have to cast it. And again now, division, and like that, and like that, double. Try search this search word war array of I 0 plus 0.5, and we have just written the logarithm pretty fast. Now we will call the try search, and we will write our first new struct, the score list. So let's begin. Try search var array vi 0. Here we'll have the score list. So this, what we'll do, we'll find the search function will find all the first of all we'll write the score list. So control N, excuse me, so control N, score list dot and score list dot cpp, and inside here you will we will write it's the list of the scores of each word. So of each document, I mean, excuse me. So let's begin. Include iostream, include stdlib, and inside we will add the guard as well, if not defined. Score list h hashtag define score list h, and if perfect. Inside here we'll write our class score list perfect. Um, we have the document ID, int ID. The ID is about um, it's the ID of the document that has a word of a search query, that has a word that is contained inside the search query, and we have a score list star next, and we have a public right here, public score list int did document ID equals -1 by default, ID did, and next equals null, and we don't have a destructor, we don't need one, I think. Actually, I think we need one. Yes, we need one, a destructor, so I will write it down. So now we have written the score list down. We will pass it to the make file as well. Score list.o, score list.o, score list.o, score list.cp, score list.h, and like that. Perfect. So let's make it a little bit right now. Score list is not defined, so we have to add score list to try not dates, include score list dates. We have to add it to inside our search.h, I think. Include score list.h. Let's try again. Score list search as alternative score list. Yes, because I've forgotten to create a score list, to create a new score list right here. We have to create right here a new score list. Star score. Now let's create the search function. Let's go to the try node.h, and the reason we are doing this is in order to create the search. Void search car star word in current index and score list star score list, and try node.cpp, void score search, excuse me, search car star word in car score list star score list. Okay, now we go to the search, what we want to have inside our uh, what we want to have inside our what we want to do about the search function is we want to pass the ID of the documents that the word access query are in. We want to pass all these IDs inside our score list. So the way for us to do so, it's pretty simple. We will go to the search dot we will go to try-node.cpp, and inside here we will write the search function again. It will not be different from the other one, but we'll have something a little bit different. So if word car equals to value, we'll follow the same path as before, else identifier value is not defined. Most probably a little bug, as you can see. Yes, I forgot try node. Excuse me. If car equals strlen word minus 1, if list different to null, then we want to return list pass documents and score list. This will be a function that we'll write right now, else return. So the pass documents functions, we go to the list, to list nodes here, over here, we go to list node over here, and we will write a new function. The new function will be void pass documents score list, and the job of this function will be to update the score lists in order to have inside all the appropriate IDs. So we go to list node .cpp over here, and we write down, it will be pretty simple, list node pass documents score I don't know, and so score list insert ID. Excuse me, over here. Score list insert ID. Score list is undefined. Include score list. So we'll insert our ID. We will write the function in a moment. We want to insert the current ID, and if next it's different to null, go to the next as well. And follow the same procedure. So we go to score list, which will be right here. We write down the function void insert, which will have int did, and this function, I think it will be pretty simple, the insert function. Wait a moment. We go to scorelist.cpp, and inside here we will include scorelist.h. We will using namespace. Oh my god, namespace std. And right here we will first write the destructor because we forgot previously. Scorelist if next different to null, delete next. Perfect. And then of course it will delete itself. So let's begin. Void scorelist insert int did. If id of the scorelist equals did, that means that it's already inside. The ID of the document is already inside, so we will return. We don't need anything from it. If ID equals -1, that means that the score list is not initialized, so we write down our new document ID. Else, what we will do, we will check for the next one. If next equals to null, then we will create a new document. Next equals new score list did. Else, next insert, do the same procedure recursively for all the list. So this is it, the score list. And yes, okay, perfect. Now what is the mistake here? Insert scorelist has no member insert. Where is scorelist cpp? This is the insert. Scorelist.h insert. So it has an insert, but list node has a bug again, I think. So let's close it one more time. And list node, I don't think, yes, perfect. So everything is smooth. And let's go to the search.cpp. We have done the search. Where's our search? Okay, so let's close everything because we have a pretty big difficulty knowing where we work on. We make file is closed, more dataset is closed. So let's go to search.cpp. Perfect. Let's go to scorelist.cpp. Perfect. Let's go to trynode.cpp. Perfect. Where search is created. So we create the past documents just now, I think. Inside trynode list, and we need the list node. We create the list just now. We create the past document, and now we need to create the search. So we go to the trynode and we check for the children again. The child if child difference to null, child search word car plus one score list, else return. If sibling different to null, sibling search word car score list, else return. So guys, again, what we are doing right now, it's pretty simple. We are checking if there are any children, then we will go recursively and check again and again if we will check again and again if everything is we'll check if siblings, if childs, if they are not, then we'll return recursively back to our target. So this is the search function. Let's go again back to our search.cpp. So after we want to go to the next word, so token equals strtoc null like that. Now we want to find average. We want to find the average. I've actually forgot something. We may use later I int I in order to have the number of words that were given to us, of course. So let's get the average map size double average dl equals 0 for int m equals 0 m minus m get size m plus plus avgdl plus equal excuse me, like that. Plus equal double map get length of m, and now in order to get the average okay, perfect. And now we have a score, double score equals 0. We'll create a temporary list which will be equal to score list. Max heap. Now we'll introduce our secondary we'll introduce our secondary the second struct that I told you we will, it's a heap, a heap structure. It's a very basic structure in C, and actually generally it's a very basic struct. And today I will tell you um, how we will implement it. First of all, we created the temp list in order to iterate through all the score list. That is the reason we create this. Uh, we create this pointer. So let's now create the new the the new function, the new struct. Perfect. Now we have created all our structures. Let's add it here as well. Perfect. Actually, we haven't make it. Perfect. It compiles, no errors. Again, let's pass some like that, some header files over here. Like that, we don't need the make file anymore. Let's write the guard if not defined max heap age, hashtag define max heap age, and if class max heap. Perfect. And inside here we want to include max heap.h. So what we want is to iterate through yes, to iterate through. Now it's how we will. Now it's the important stuff of. I will write down the important stuff of how we will implement. Let's say how we will have how we'll sort the scores, and the scores how will be given. We will check for each uh, word, for all the documents, and we'll have a logarithm about it. The IDF is the logarithm, and let me a second to explain to you better. Uh, so the IDF is actually it's actually considered from the logarithm that we get before, and now in order to find the score uh, the score for each document. Each document will have a score. The score of each document is the ha- uh, the logarithm. The logarithm is that. Let me for a second uh, get it out to you. This is the logarithm. The score D is the document and Q is the query. So IDF is that we find before over here. That the F is the frequency of a given word inside the query. N is the number of the words. I through N, so I through N, and IDF is for a specific word what was the score of the word, and decide a frequency of the word inside the document. K will be a constant that we'll write down. B also will be a constant, and this is how we will. D is the number of words inside the query, inside the document, because if in order for us to have a reliable query, so this is what we will try to write down. You can print it, maybe actually. Let's zoom in a bit. How you zoom in? How do you zoom in here? Yes, I cannot find out. So this is what we'll write down right now. It won't be that easy. It won't be that difficult, but we don't care about that because the purpose of this tutorial is not to know the logarithm, is to know the basic struct on how a search engine, a basic search engine works. So let's delete this over here, and excuse me, and here we are. So max heap. So now we have created the max heap. We'll write, first of all we'll go to search.h that include the max heap, include max heap, and inside here we'll write max heap star heap equals new max heap. The k will be the number of the words because the number of the results, if you remember at the beginning when we write down for example minus k2, only two results will be given, will be shown. So here we want to initialize with a k as well. So let's go to the max heap here, and what we want to do is pretty simple. Max heap int k. So we go to maxheap.cpp using namespace st, max heap int k, and inside here we will initialize the max heap. So let me give me a second. the heap will have some very important variables. This will be public, of course, my bad, perfect, and this will be a heap, not like it will be an array, like so double star heap int star IDs, the IDs, int car num of scores. What is the maximum number of um, of documents scores, and we will and after we will add some function as well. So from here we go to the maxheap.cpp. We will create the insert function very fast. Actually, we will create first of all the function that will initialize max num of scores k, car num of scores 0, heap equals double star malloc max num of scores size of double. IDs equals int star malloc max num of scores size of int. Yeah. Right now I've just created the heap, and now let's go and do the logarithm that I told you about. For excuse me, while template is different to null, for int l equals 0, l minus y, l plus plus, score plus equals idf, l, I'm just writing down the logarithm, nothing more. Now let's write down the constants. Const float k1 equals 1.2, const float b equals 2.75, score list GBP. I forgot to write, I think, yes, inside score list. Let's write some functions. Score list star get next, return next, and it get ID, return ID. Here we are. k1 plus 1.0 double. So all this will be divided by another part here, double try tf search word um, temp list get id var array of I of L, excuse me. But tell me that I haven't, yes, I don't haven't done the same mistake again. 0 plus k1 plus p. I get the length of temp list get id perfect, and of course at the end that. So this whole part was just for the score, nothing you need to know here. Now heap insert score temp list get id. So we passed inside the heap the score, the id. We make the score 0 again in order to prepare it for the next, and temp list get the next, and seal will create a new one, int seal right here equals 0. Seal is the number of the prints that we'll have at the end, how many prints we will have. So C++ seal like that. So now let's go to create the insert function for the heap. Let's go to the heap. Heap.dates. Where's the heap? That's heap.dates. First of all, for free IDs, void insert, double score int ID. So now let's actually we'll need some more functions for the insert, just for the insert. So we'll have the remove, of course, int max child, int number 1, int number 2, double remove. We'll create all the functions right now. Get ID, return IDs, the first ID. perfect. And right here we need two secondary functions that will help us swap scores. Int index1, int index2, int min index, int low, int high. So, perfect. So now let's go to maxheap.cpp and we have some code to write. Actually, I will write it down at the next tutorial, guys. In order not to have too large video, I will name the next tutorial, the next video about max heap. So bye, guys. Hello, guys. So at this part of the tutorial, we'll talk about the max heap. The max heap is very widely used struct in C. It is pretty simple actually, not that difficult. It has insert time complexity O log n and average and worst case, and I will show you from Wikipedia simple stuff of a simple over here. So this is a min max heap. No, we want the max heap, sorry. Binary heap. Here it is. This is a max heap. That means that every level has lower level than the upper one. So 119, 17, 3, 2, 7, as you can see. This is a min heap. Yes. This is a binary heap. If a new element is installed, 3 for example, here will be a new leg, 7 for example, 7 is bigger than 3, is bigger, it will go here, 7 is bigger than 19, no it's not, so we'll stay here. We'll stay 7 here and 3 down there. And so on and so on, nothing too special. I suggest you study it a little bit. It's very basic, I suppose you know it, what a heap is. And we will write down the code to achieve a heap. So let's start with the insert function. Int index if car num of scores different to max num of scores, y if car num of scores different max num of scores, then index equals char num of scores and char num of scores then plus plus. Else so now we want to create a space so that if car number of scores equals max number of scores, that means we have reached the capacity of the maximum capacity of our heap. So we have to find a way to free some space. So the way is pretty simple, and the way is pretty simple. Int temp index equals mini index max num of scores divided by 2 max num of scores. We check what is the smallest index from those two, and if score heap temp index is smaller than index, it's bigger, excuse me, index equal temp index, else nothing will happen, and as it is no space for it inside the heap, so return. Yes, it will return. And now we have to write the mini index. It's not that difficult. We have int max heap min index, int low, int high, int min equals -1, double min score equals a really big number, for int I equals low, I min high, I plus plus, if heap of I min score smaller than min score, then min equals I and min score equals heap I, and return min. So what this function does, get the minimum of all the leaves of the tree. This is what it does, get the minimum. It returns the minimum index behind, it returns the minimum index, and this is why this happens. So heap index equals score, ds index equals id, while heap index it's bigger than heap index -1 divided by 2, swap scores index excuse me, and that one here, swap those two, and that right here. Change the index. Perfect. And now we have to create the swap scores function. It will be pretty easy. Just we will swap the index and the scores pretty fast. Void max heap swap scores index 1 index 2 double temp equals in order not to be casted wrongly as an integer, that's why I'm initializing like that. Heap index 1 and now we have to reverse all of them, so the way to do so is temp int temp id equals ids index 1 heap index 1 equals heap index 2 heap index 2 equals with temp, and following the same ids index 1 equals ids index 2 ids index 2 equals to temp id, and everything is changed pretty much. So swap scores is perfect. And now I suggest we write we want to write the remove function. Let's check a little bit. Let me remember the algorithm for a second. Yes, we want to write the remove function. So the remove function is pretty simple. Every time we remove the header, and then we take a leaf and place it to the top, and then we go until we find then the leaf goes down, the value goes down until the max heap is correct again. So let's write it. We have two more functions to write, the remove and max child, which we will use inside the remove function. And so double max heap remove index equals 0, and we have a chosen child, double return value equals 0 if car num of scores bigger than 0, so we haven't our heap has still something in it. I made a mistake here. Then return value equals heap 0, which is the header of the heap, and after char num of scores equals minus minus heap 0 goes with the last leaf, as I told you. So heap char num of scores, like that, and so IDS goes the same. And so this is what we will do right now. Chosen child equals max child from index 1 plus 1, index 2 plus 2. So index 1 and index 2, as you can imagine, are the children of excuse me, no, index 1, my bad. Index are as is a constant, is a variable that if you add 2 times index plus 1, you will go to the left side. 2 plus index plus 2 times index plus 2 goes to the second child. So we will get the max child from these two very fast, but wait a second. So max child returns the biggest child from these two. Let's go with that. So if there are no children, it will return -1. So if chosen child difference from -1 and heap chosen child bigger than heap index, then what we will do, if why though, I forgot to add the semicolon here, then we will have to swap scores between the chosen child and the index, as the chosen child has to be at the top of the heap. Else break, and here, right here, we have the return value. Now we'll write the max heap, the max child function. If number 1 is smaller than current number of scores and number 2 is smaller than current number of scores, that means that there is a left and a right child. Then we have to compare between the two of them, number 1 and number 2, and the indexes, if you remember. Number 2 minus smaller current number of scores. If heap number 1 is bigger than heap number 2, then return the biggest, number 1. Else return number 2. And number 1, number 2. Perfect. Else if number 1 is correct, is inside the car num of scores. Then return number 1. Else if return -1. Perfect. So max heap is created correctly, perfectly, nice. And let's go back to our searched PPP. Actually, child. Max child is undefined. Max heap, max child, max heap, max child. Yes. Ah. Perfect. So we have just written the max heap. Let's go to our sets.cpp. Actually, I don't think we will need anything from it right now. List nodes, score list, if I don't remember anything. So sets.cpp. And where it is, yes. So, we have to check if the seal is bigger from k, then we have to be sure that it's equals to k. And now I will show you the last part before we go to the print, which will be a separate video altogether, the print, the output, and how we can achieve this. Struct win size w yoct1 std out fileno t ioc cgw incz. Give me a second now. Search the dates. We want to include two inside here. to include these two. So let's check it right now. Yes, my bad. Yeah, let me ah here. Let me try to write again because I made a mistake, I think. And see out dot rows, for example. Now check it. Where we got stuck. Maybe I have passed something wrong. I have rewritten the code, so let me pass again the part here in order for us to be sure that nothing is wrong. Let me check again, because the problem was inside this part. Somewhere it does not move. Site search, input manager. See out one here. goes out from there. So I guess this is where it will stack. Why though? Well, temp list. Ah, yes. Oh my god, pretty bad. Temp list equals that. So let's try again. Uh, 23 is the row. So if I, as you can see, it's 23 the length. If I make it like 15, search hello, 15. I think it's pretty amazing. We get what the length, the columns we will care about, and we will care about. So at the next video we'll write the search functions. Bye guys, see you at the next and the last video of our tutorial. So guys, this is the last video of our tutorial, and now I want to show you how we want our last format to be. So let me open my snipping tool again. This is how the format, how we want the format to be. We want it to have, first of all, the 3, 4, 1, for example, will be the logarithm. The higher will be first, and the first is the ID of the document, and are the keywords that we want them to be underlined. But in order for us to underline the correct words, we must to find where exactly are inside the line. So this will be I think a little bit difficult. So we have to begin. This is the format that we want to. So let's start. Where we are, yes. So if you remember, the seal is the number of seal is the number of the results for int l equals 0, l plus plus. So for each we go for each different print. So int id equals heap get id if id equals -1, then we want to break because that means that we have reached the end of our heap. Then now if we haven't reached the end, then we will return the top score, the biggest score. So score equals double heap remove, and we want to print the ID. If you remember, we want to print the ID. cout like that, id, and now I have calculated the number in order, let me show you one more time. I have calculated snipping tool. I have calculated the number from here to here. This is 10. That's why you will see that I use 10. Excuse me, no, not for that. I will explain to you in a second. The 10 that we'll use right now is for normalization. While d my different from 0, this will never be 0, but because the id is an integer, when we divide from the with he, sometimes it will be a double, and so it will be 0. For example, 1 divided by 10 will give us 0. F++. So now we know how big the ID is of the document, how big the ID is of the document. Now we want to create a normalization. So while 5 minus f, we use 5 because we're saying that we're using like 10,000 documents on 99,999, but if we had more documents we would use 6, 7, 8, no problem, it would be the same. Just one line of code would change. Cout like that, cout with a space, and f++. Perfect. Now we want to print the score. We want the score to have a certain degree of precision in order to be sure that it will not destroy the lines. So the way to do so is pretty simple again. Printf, going to close from before. This is from here. We want to close it, and like that. Perfect precision, and the score. Now we'll get the line. It won't be that difficult. From now on, that was the difficult to understand part. So from here, excuse me, from here we will go like that. We'll get the line, car star line, car star malloc map get buffer size, I think size of car, yes, strcpy line with map get document id. We have now the car start temp. Temp equals str doc line so now we'll initialize some basic values. First of all, we want to know where the current length is, where we are in terms of our lines. So int car length, because now we are beginning, equals 0. Int counter, the counter will check if we are the first line of its answer. If you know what I mean, this is what I mean. This is the first line. So if we had quick brown foxes leaked over lazy dogs for fun, and then it will continue with a second line right here. This is the first line. This is the second line. So this is what the counter will count. Int new line equals 1. We'll check if we have a new line. Int line flag, if we must underline words under this line. And int underline contains the place that we must underline exactly. Int u counter is an underline counter, nothing more. So while temp different to null, now we'll check if it is a new line. If it is a new line, then the current length shall be added 20, because we don't have all this stuff at the beginning. Excuse me. Because we don't have all the stuff at the beginning, so we have to add 20. So how we'll do this? Pretty simple. Car length we want to add some spaces at the front. Perfect. And now the new line will be 0. And now after that, for int n equals 0 and my smaller than I n plus plus, we want to check if we want to check if a word is inside a line, a specific line. So we want to check the temp we want to check if a word is inside the line. Um, Pretty simple. So if it is inside the line, then if car length plus strlen temp plus 1 equal it's smaller than w we should call, then underline 0 and counter strlen counter counter, excuse me. Oh my god, what I am writing. Counter, it's the underline counter that equals with current length underline 1 counter equals strlen temp counter plus plus because we will go to the next position, and line flag equals 1. This means that at this line we have something to underline. So after the for loop we go after and we go wait a moment, car length strlen temp plus 1. We increase we increase the column that we are at. We go to the next column. Because we have written a word that we have to underline. That's why we are increasing the number of columns that we have to pass in order to go to the correct position again of the current length. So if car length minus 1 is bigger than WWS call, then current length will be turned to 0 again. Turn to 0 again. New line will be 2 equals to 1. C out and L. And if line flag, if we had words to underline, then we will have to output the new words. We'll have to output these little symbols over here whenever it is needed. So if line flag car star output line car star malloc, excuse me, car star the size should be plus 1 times size of car, of course, for int j equals 0, j smaller, call j plus plus. We want to initialize all the output line in order for it to be empty. So in order for it to be empty, so what we'll do now is output line equals empty of j, of course, equals empty, and of course we want to we want the last part of the line. The last part should be output line will be a terminating character in order to be sure that everything is okay, and the line flag should be equals to 0 because right now we have to reinitialize again. Yes, okay. So we reinitialize line flag, we reverse it to its starting point. For after we have to place the little symbols wherever is needed. So for int j equals 0, j smaller u counter, j plus plus, for int v equals underline 0 and j v smaller underline 0 and j again, plus underline 1j, actually we won't need like that, so the output line should be filled with that. U counter equal to 0, cout output line and free output line, like that, and we have free the output line. If it doesn't go we want to continue here, and if everything is okay, it is not, then we want to see out the temp, the rest of the temp, and temp equals strtalk null again counter plus plus Um, oh my god, I forgot. Oh, that was bad. While them it's different to null, should go. Yes, I was like, why? So perfect like that. And here after, when every word is finished, we'll call endel so what we're doing now, we're taking from the map every word separately, and yes, we take every word separately, and when we finished, we check every word if it is inside the word that we have to underline. If it is inside, then we underline it, else go to the next. So when the line is finished out and del, free the line and free of course the temp again, like that. Now we want to delete the heap, delete the score list, and cout and del. So yeah, so let's see. Uh, I think I think guys I forgot something here, so here we are. It goes right here, here, it goes right here, here. Okay, while for this is the problem. We have no, for loop is like it's correct. Yes, this is wrong. So let's take it again. Perfect. Search. Hello. Guys, how are you? Um, well, we have, I think, a major mistake somewhere, but the part about underlining is correct. Let's exit. We have 0 errors. So let's not val grind because will take a lot of time. Let's do the same with a big data set. Let's wait a little bit. You will see how fast it is when we don't run val grind. As you can see, it was pretty fast. And so search hello. Yes, we have a problem. Search, find. Yes, here we are. Okay, we have a problem, so let's fix it a little bit. Whenever, I think I know where the problem is. I forgot here pretty to check if it's a new line. If new line, if new line, then like that, like that. And now let's check it again. So search hello. Perfect. We go like that in front. Search, find, hello. Here we are. As you can see, it creates an empty line whenever a word is found that we are searching for. And now I will write a big query. Let's write all this as a query. So if we go to the first text, of course, these are the two main articles that have the best points. Now let's change it a little bit. Let's collect it. Let's call again with like 10 results, not that small. Because I gave it the empty, no, not at all. I cannot understand why. So search. Now 10 documents are shown. 3, 4. Ah, no, my mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 documents. So this was our search engine. So if we write that, as you can see, it found exactly the article that we are searching for. That didn't show me the will. So you were searching like a user. So for example, job pavey, great Edinburgh, for example. Job pavey, great Edinburgh. Let's write search job pavey, great Edinburgh. So let me check. Job pavey and great Edinburgh. Pavey here, Great Britain, and so as you can see, it works pretty much like a regular search engine. Um, we learned some stuff, pretty important stuff at this course. I think uh, I think it was very interesting, as you will learn a lot of structs, such as such as um, mapping, such max heap, a try, a lists, arrays, and you know how you can use memory efficiently. So guys, I hope you learned a lot through this tutorial. It was really fun for me, and see you at the next tutorial project. So bye guys from me, see you soon.